Hello everyone. So Techinforay is back with another video. I got queries from students and cloud learners that they want to start with playing with AWS console and bit confused how to start. So I have created this video that how you can launch your first AWS server with the default settings, and you need not to worry about a lot of configurations and all that. So just you need to click next, and you can create your own Windows server and Linux server. So I have created this video to run through these steps, and you can easily create your servers and launch your server, and you can play around with that. And also you can install your applications and all those, whatever you want to do. So in this, first of all, you require AWS free tier account. And in case you haven't created that, I have mentioned the link in the description of this video. You can follow those steps to create your free tier account, and then you can log into AWS console. So if we move forward, this is the conceptual diagram. So we will create two servers on AWS, and one is Windows 2019 server and Linux server. So you can create these servers, and on the AWS, we will create this in Mumbai, and this is one of the region of AWS. So as per the country location, you can select your own any of the region and create your server. So currently I'm located in India, so this is near to me, so I have selected this one. And once the servers are ready, so from your laptop, you can connect over the internet. You can access these servers. They will have a public IP address, and you can access those servers from your laptop, and you can work on them. So that was just for understanding the conceptual diagram, and that's just for understanding. So let's go to AWS console and create Windows machine, and I'll mention the steps how you can create it. So here we are onto our AWS console. So let's sign into the console, and so here you need to select a root user and the email ID that you used while creating your free tier account. So put your email ID, click on next, and let's put this security check. Submit. Put the password that you selected. Okay, so we are into our AWS console, and as I suggested that we are going to create this in Mumbai region. So I have selected this Mumbai region. So as per your own location in the world, you can select nearest one, the region in near to you, so that you can have good speed of the instances. So this is the first landing page of AWS console. So these are the recently visited services. In case you do not find them, click on services, and you can see all those services. So to create this instances, let's go to EC2 instance and create an instance. So click on launch instance, and then here is a list of servers, operating system that can be installed on the server that you are creating. So you can select any one of them. So here we are going to select 2019 server, and it's eligible for free tier. You're not going to be charged for this. So let's select that one. So these are the different configurations that you can select out of it. So this is free tier eligible, and you can select this one. So for demo purpose, I'm selecting this one, and you can select anyone as per your requirement, right? So these are all different configurations are available. You can select as per your project requirement, the biggest machine that you can create. So you can select any one. So click on next. So here keep all these default settings, and just enable the public IP address on which you are going to access your server. So it will be, this IP address will be automatically assigned to the server. So just enable it. Add storage. So by default it's 30 GB. If you want more, you can increase that and add more volume. So as of now it's 30 GB. So let's select that. and tags, keep them default, create security group. So here by default 3389 is allowed, so we are going to connect Windows machine on this port, so that is allowed. If you want to add, like if you want to publish any website, you can allow any of the port, like we can allow HTTP if you want to publish some any website over the server or any application. So whatever port you required, you can allow that over here. So you can add any of the port that's required. So review and launch. So you need to mention the IP address. Okay. Review and launch. So this is the configuration that we selected, and click on launch. So here, what you can do is you can create your new key pair. Let's give name test demo 1 and download this key pair. So we will save this keys in AWS keys, create your any folder on the desktop or on your local machine. So save it and click on launch machine. So you can now click on view instances, and you are there. Your server is getting ready. So within 2-3 minutes, this will get ready, and then you can connect it. So we can give this name demo Windows 2019 server demo. Sorry, save. So we can give this Windows 2019 server. This will get ready in few minutes. So for the time being, this is getting ready. So I'll pause this video. So I'll resume it once this is ready. So this takes just 2-3 minutes. So once this is ready, I'll resume it. Okay, so now you can see our server is in running state, and status check all are passed. So now let's connect to our server. So select the server, click on connect, and RDP client. So here are the details. Username is administrator. Let's generate the password for it. Get password. So browse the same key that we generated during our server creation. So browse that key. So AWS keys, test demo. We are going to select it. Open, decrypt password. So now we got our Windows administrator password. So let's select username as password. Let's save it in the notepad file. Administrator, password, this one, IP address. Let's go to the instance, and you can find the public IP address, this one. So this one. So our server is ready. So let's open Windows utility remote desktop. To connect it, click on run. So mstsc. So this is remote desktop connection, and you can open that in your laptop. This is by default installed. So click on this, connect. So more choices, use different password. So here you can use administrator username and password, but most of the time, mostly there is security on the laptop, so you will not be able to connect. So you can also use root/administrator. In case administrator do not work, then you can use this one, root/administrator. Copy password, paste. Okay. So now we are connecting our Windows server. Yeah, we have successfully launched our server, and now we are connecting our server. So we are ready to use this server. So in few minutes, our server will be ready to use it. So hold on for a few seconds so that it can make some initial settings, and then our server will be ready. So this will be ready in a few seconds. Yeah. So one more setting you can do, the security in 2019 is quite high. So for few minutes you can disable that, and then you can browse and install those things. So open Windows Server Manager, and we can disable the security for a few minutes, and then you can enable again, because you will not be allowed to install any application or something like that. So go to Windows Server, local server, and over here, IE enhanced security configuration, it's on. So you can put it off for administrators. So now you can access anything and install anything on the server. Google.com. Okay. Yeah, so our internet is working, so you can download anything and install your application. So that was how you can create your server. And also, if you want to make this as a web server, you can go to dashboard and add any role. Click on next. So role to be installed on this server. So like we can quickly install IIS to publish the web server. Add features, next, 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 install. So this will take a few minutes once this server is ready. Okay, so our web server is ready now and it's installed successfully. Let's close it. Let's open Internet Explorer and see our local site. HTTP localhost. Yes, it's working successfully. So if we want to publish our website, we can do that. Like, let's go to the server root folder and we can edit some files. inetpub www-root. So let's edit this file. Open with Notepad. Delete. This is demo Windows 2019 server. Control S, save, close, close. So let's refresh this. Yes. So also, even if you open this IP address over the internet, let's try that. I think it should be able to access it. So we can use this IP address, public IP, on which our server is allocated. So let's copy this public IP. So you can copy it from here, or you can copy it from the notepad. So wherever you have saved it, you can copy it. So if we open our Internet Explorer or Chrome, if we put this public IP, yes, so we can see this this server is published over the internet. So you have successfully published your web page over the internet. So how easily you can create that, right? So that was the demo for creation of Windows Server. So let's go back to our console and let's try to launch our Linux instance. So as per the diagram that I have shown you, so far we have created our Windows Server, and this is done from our laptop or desktop. We are accessing this server and then using the public IP that was assigned to this server. We installed IIS service, that is web server, and we have published it over the internet, and we have published our web page over the internet. So see how easily you can create your web server and install a web server and publish your website. So let's move forward, and then let's create now the Linux server. Let's get back to our console. Now click on launch instance. So here we can select this Amazon Linux image and click on select. Again, the process is same for selecting the configuration. We are going to select this configuration for this demo. Click on next, configure. We will keep the same, just enable the IP address, public IP address that will be assigned to the instance, and click on add storage. We are going to add 8 GB storage. If you want more, you can add that. Next configuration. So launch wizard. So here again, this security group will be created for this. So we can add HTTP if we want to publish anything over it. So review and launch, click on launch. So we are going to use the same, the key pair that we used before, test demo 1, that we created it before, that we are going to use the same key pair over here. So click on launch instances. So click on view instances. So let's rename it Linux server. Save. So this will again take 2-3 minutes. Once this is ready, I'll resume the video. So let's wait for a few minutes. Okay, so our Linux server is ready now. It's in running state and checks has been passed. So let's select this. So this is the public IP of Linux server. Let's copy this in our notepad. This was the Windows server details. So Linux server. Okay, so to connect this Linux server, this is a bit different. We will connect on PuTTY. So first, before connecting to PuTTY, we need to drive private key out of it. So let's open our PuTTY gen, and we will create our private key out of it. So click on load, and we will access our private key, all files. So let's select test demo, open. Okay, save private key, yes, and private key, save it. So we will use this private key to connect our Linux server. So let's open PuTTY, and let me copy the public IP address, paste the public IP, and now go to SSH auth, browse the private key. So here we have gone to our keys where we stored private key, open, click on accept, that's it. So now we are accessed our Linux server. Username is ec2-user. So we are authenticated using our the private key that we are. So now we are into our Linux server. So let's publish quickly our web server over this. Let's get into super user mode. I have copied some of the commands that are ready to use. I'll mention those in the description. You can use them. Let me open those commands. So here are the commands to install a web server over the Linux instance. So let's install the HTTP web server. Click right click and it will be copied, and we can install web server over it. So check config, run the service. You can use this, just copy paste service, start the service. Okay, let's edit the file, rename the default file. Let's create our own file that is test page on Linux instance. So you can use this. So I'm just editing the index main file that we did in Windows Server. So similarly, I'm editing the index file in Linux Server to create our own web page. So you can use your own web page to publish. So I'm using this single line and editing the file. So that's it. Restart the server. Okay, so our web server is ready. So if we use the public IP of our server similarly that we did, so let me open the Explorer. This was Windows Server that we published. Let's publish the, yeah. So we have published the web page from the Linux instance as well. So see how easily we can create our servers and publish our web servers and publish our web page over the internet. So I hope you have understood how we can create servers and create login details, and once this is done, go back to the AWS console. Since you do not require these servers are no longer required. Do not forget to terminate them. So select these servers and you can click on instance state and click on terminate them. Click on terminate. So these servers are going to shut down and will be deleted because you no longer require them. These can be deleted to save the cost. So that was it. So as per the diagram, we have created these servers and published web servers over Windows and Linux instance accessed from our laptop, manage these servers and publish the web page over the internet, both for Windows and for Linux. See, I hope you can use this video to play around and create your own servers over AWS console and follow these instructions, and you can do that easily. So that was it for this video, and I hope you have enjoyed creating servers in an easy manner over the AWS cloud. In case you have any queries, do not hesitate to ping me and I'll try to resolve your queries. So thank you very much. Follow the instructions, create your servers, enjoy. Thank you very much. Hello, everyone. So I hope you are doing good and safe at your homes. So Techinforay is back with another video to enrich your knowledge for cloud and other important aspects to design a solution. So this time I have created a video which is very important to create diagrams, and this is important because whenever you are creating some solution, it's very important that you should create a diagram for it. And diagram, I mean to say the solution components. So in this video, I'll guide you like the importance of diagrams that needs to be created, and the need for diagram, why you should create these diagrams, and who will be benefited for this creating the diagrams. So also it's your benefit also, like when you're creating some solution on the cloud or anywhere, just create your habit that you should create first create the diagram and then start implementing or configure the solution. So it's very important. Again, I'm stressing on it that while doing anything, creating some design, create the high-level solution design of whatever you are doing on the cloud. So let's move forward and let's see why diagrams are important and why it should be created. So the importance of solution diagrams, the agenda will be like high level of the solution. These diagrams shows the high level of the solution, and you will be able to understand the solution components and traffic flow. Components like there are different components like network, storage, firewalls, internet gateways, and regions, availability zones, and different subnets, networks. So when you are creating a solution diagram, it shows all the different components and how traffic is flowing between these different components, and it's very easy to understand the flow or traffic flow, the solution components of the diagram of the network architecture that is there, or solution architecture that is there. So from the diagram you can easily understand that. And also placement of solution components, how the different components are interconnected, dependency of the solution components, how each component is dependent on each other, and what all ports are allowed. So also by using these diagrams, it helps to plan long-term strategy, like if we want to add something next year, or after 2 years we will add this and we will place that here, and that will be our extension area. So that's how we can plan our long-term strategy for our business, for our IT infrastructure, or for our network infra or storage, whatever we are planning in the long-term strategy. So from these diagrams, it's quite easy to plan long-term solution design. Also, in case there is some problem, it also helps in troubleshooting of the problem. And also another important aspect that the audience, while creating your diagram, keep in mind the audience to which you are showing this diagram, whether it is technical audience or whether it is business audience, or what kind of. Accordingly, put the information in the diagram. So that's very important. So the first aspect, understanding the solution. So using these diagrams, you will understand the high level of solution, and as I mentioned before, you will be easily understand the solution components and how traffic is flowing, what all traffic is allowed, and between different components, what all ports for the solution components are allowed, and you can easily understand the clear picture of what is being allowed and what's being denied. So for the ports, you can easily understand the traffic flow, the ports that are opened, and the solution components. And if we talk about exposure to internet, you can also understand what our ports are allowed towards the internet, towards internal systems, or towards different subnets in the network. So you can, from these diagrams, you can easily understand what all is exposed, what all ports are allowed, and how the solution components are placed in the network, in which subnet, or on which zone they are placed. So network or zones or subnets, they are same thing. So these are created to segregate different networks. So when we are segregating the networks, we can understand how networks are segregated in the solution architecture, what all different subnets are created and network zones are created. So either it is subnets or network zones that we can understand from the diagram. And also when we get the information about what all ports are open and exposed, we can see how subnets are secured, and we can get that information, which subnets are public, exposed over the internet. So we can see just by the glimpse of the diagram, so we can understand what all subnets or ports are allowed, and the interconnectivity of solution components, how different components of the architecture are interconnected, what all traffic is flowing, and which solution component are connected to which solution component. So in detail we can get, and what all dependencies are there, while sometimes we are changing some component in the solution architecture, or making some bigger changes or small changes, and then we can come to know what all ports are allowed. So it's really beneficial while you are creating the diagrams. So because if you see the corporate networks or bigger industries, there are quite complex components in the solution architecture, for network storage, for database, for applications, for services. So it's quite beneficial if you have a proper diagram with proper information. So once you can start creating simple diagrams and slowly move towards creating complex diagram. So the benefit is for you and for the person who is reading the diagram. So create a habit of creating the diagrams. Again, I'm stressing on that. So these really, the diagrams helps us to understand the solution architecture, what all is there. So that's really helpful. So moving forward, also when we are planning long-term strategy for our organization, uh, uh, addition of more business services while we are expanding locally, or to another part of the world, or where we are expanding, so we can, when we are expanding our business, or then we have to see integration with existing components, the expansion area, how it is being integrated. So all that we can understand from the simple glimpse of the diagram that is there. So it's quite beneficial when we are expanding and understanding in integration with existing components. So there will be more benefits also, but these came into my mind, and I try to create awareness for that. And when we are planning some change, or troubleshooting troubleshooting when there is some problem in the network or any component of the solution, then we can suppose we are planning some change in the infrastructure or network component, then we can refer to these diagrams, all the information that is there, and accordingly plan the change, what all components will be disturbed and what changes are required, so that we can, after implementing that change, we should not disrupt any service or create any problem with the existing service. So that these diagrams helps understand how we are going to plan the change and what all changes we need to make, what all different components in the solution that will be disturbed. So we can plan change management using these diagrams. And in case there is some incident or some problem, so by referring this diagrams, we can easily understand where the problem lies, whether it is network or with some storage or with some security. So by understanding what are ports that we had defined in the diagram, ports towards which components, by looking at the diagram, we can easily understand and helps us to troubleshoot the problem when it arises. And also, when we can easily solve the incidents and problems in the network, that minimizes the downtime in the network. So the more information is there in the diagrams, so the minimum downtime will be there in the whole service. Also, when there is minimum downtime, then increased availability of the services from all perspective of the architecture. So we can plan the changes, we can easily troubleshoot the incidents, and we can minimize the downtime and increase the availability in the service offering of to our clients. So see, there are different benefits for the diagrams that you created, and the information that we put correctly in the diagram, so that again helps to troubleshoot and maintain the availability of the service. So in the end, I would suggest that while creating your diagram, you need to keep in mind or create different diagrams while presenting that diagram to audience. So accordingly, keep that information in the diagrams. Like if we have technical audience, they would like to deep dive into the components, what all components are there, how they are connected, firewall rules, or these things we can show to them. But in case the audience is business audience, they are not interested in that much technical things. So they want to understand high level of the service components. So we should not show that technical things in the diagram when we are presenting the high level design to business audience. So it's very important the content that we are presenting, and what all we need to include in that. Maybe we can create different documents also, like a detail level diagram or high level diagrams, and according to that we can keep that information as per relevant to whom we are presenting that document. So keep that in mind. Main thing that I want to communicate is that while creating any diagram, keep in mind to whom you're presenting it, and who will be the audience for this diagram. Accordingly, present that diagram and create separate diagram for technical audience and for business audience. So that's main objective. And also one more thing that I want to convey is that while creating your diagrams, get it quality checked from your peers, so that what you are presenting, is it understandable? uh, the thing that you want to communicate, is it correctly mentioned, or there is some gaps, or the audience will not be able to understand. So get it reviewed from your peers, that what you have created, and you can present it. So just first quality level check, you should do that to just make sure that what you are presenting, it should be understandable. So just ask your friend to review this. So that's quite easy. Or send your diagrams to mentors, or to your guidance, and understand the thing. So while creating the diagram, you can also send your diagrams to me. I'll mention my email ID in the end, so you can send your diagrams to me, and I'll review and help you to create your diagrams. So in this video, in the end, I'll show you to create this simple diagram. This is just, this video is for beginners. So in this I have created for AWS Cloud, and I'll show these components in the diagram. So we will cover in, I'll show you how we can create this diagram, and we will cover the AWS services in the diagram, like the VPC, the AWS region, and the networks, network subnets, and routing tables, the virtual firewall, which is called security group, and access to internet gateway. And we will show like how these components are placed, because it's very important to understand like how components are placed. So, by looking at the diagram, you can easily understand how different components are placed, what's the outer region which is inside that, and how different networks are placed in the VPC, and what all routing tables are there for different subnets, and what all virtual firewalls are enabled for this. So you can see that and create this in your diagram. So in the demo, I'll show you all we will try to create this, and you can start creating your own diagrams. So it's really interesting to create a diagram, because it shows you what exactly you are implementing, and this picture gets more into your mind while creating or implementing anything, because a picture is more than words. So this will fit easily into the mind to understand the things. So just follow these guidelines, and then we can create interesting diagrams. So don't worry if you are not able to get exact things, you can easily improve it. So right now I'm just creating basic components. Slowly in my coming videos, we will create more complex diagrams. And if you want to create these components on AWS, I'll mention the link that how you can configure these components. So my suggestion is that first create the diagram, then move on to AWS Cloud to configure these components in the cloud. So it will be very interesting. So let's get back to let's create the diagram. So for this, I have installed this software Draw.io. So you can install this on your laptop and select more by clicking on more shapes. You can select any cloud components that you want to create diagram for, whether AWS, Cisco, GCP, Azure. So you can select any one out of it and create the diagram. So here I'm showing the demo for AWS Cloud. So let's create a diagram for AWS Cloud. So by starting with the AWS Cloud, let's create the diagram, and this is the outer region for AWS Cloud, and in AWS Cloud we have different regions. So as I have shown in my videos, also in the demos I have shared it, that AWS Cloud has different regions. So in each country or different regions there. So for this I am taking example of Mumbai region. So AWS Cloud has a region in Mumbai, so I have we will include that in this diagram. So as per your availability to your nearest region, you can select that and create your own diagram. So for demo purpose, I'm using Mumbai region, and accordingly you can configure that. So in regions, we have availability zones. Sorry, not availability zones. In the region, we will create the VPC. So select Mumbai region, then we will define the VPC. So VPC, let's create a VPC hyphen Mumbai, and let's define the network 10.0.0.0/16. So let's make it a little bit more and readable. Okay, let's change the color as well, black one, so that we can easily read it. So also before creating the diagram, also plan what networks you are going to plan and what are these subnets that you're going to plan, and accordingly. And also one more thing that I want to convey is that the naming of the VPC and subnets, plan that as well, so that it should not create confusion while you are moving towards complexity of the diagrams. So here I have kept VPC, I'm creating a VPC in Mumbai region. So I have kept VPC hyphen Mumbai 10.0.0.0/16. So in this VPC, we will create public and private subnet. So let's create public subnet. So let's put one public subnet. Let's rename it PS hyphen inside VPC Mumbai. And let's define the network 10.0.1.0/24. So that's how we define the subnet. Let's define another subnet, private subnet. So let's rename this PRIVS hyphen VPC hyphen Mumbai 10.0.2.0/24. So that's how we have renamed our networks. Let's make it bold. So you can see how we have defined it, and after this we need to define the routing tables. Let's create the routing table out of it. Select title and let's create a table of 2. So that's how we are going to define the, let's keep the name for routing table as well. So we need to define the routing table for subnets to allow what all is allowed for those subnets. So let's rename it RT hyphen V public subnet hyphen VPC hyphen Mumbai. So we are creating this routing table for public subnet for which is in VPC Mumbai. So for this, for the routing will be like for local 10.0.0.0/16. It should be routed locally only. Local. So that's how the route will look. So currently we are adding for local only. So let's add defined routing table for public subnet also. So let's rename it PRIV, private. So again, to reach to local subnets in this VPC, you should go local, not any outside. And let's define the security groups, the virtual firewalls, title, So let's define it, and we need to control the access also. So it's very important. So this is how it looks. Let's change the color to red one. Okay. So in this, we have mostly this is general information that I'm going to put to for understanding only. The rule ID. Then we have to mention the protocol, the ports, port range or ports, port range we can mention, and then we have to mention the source, then destination where it is allowed, and then action. So let's rename it security group for public subnet for VPC-Mumbai. So whatever it's placed, all the compute that's placed in the public subnet, these rules will be implemented on that. Let's create Control Z. Create the security group for private also. So this is how the diagram will look like. So let's define the internet gateway. Let's go to network components. Server, storage, networks. So here we can select the network, cloud directly, API gateways, networking. So this is the router, and this is the internet gateway. So these are all the icons that we can use in network services. So once we will create more complex ones, so we will use these icons. So for the time being, let's use the internet gateway. So if we see practically, we are going to attach this internet gateway to the VPC. So let's attach it. IG internet gateway VPC Mumbai. So let's make it a little bit smaller. So this will be attached to VPC. That's why we are placing it over the edge of VPC. And let's connect over the internet. Let's get the internet icon. So this is our internet. So from this one, let's create connection towards internet. Let's go to arrows in the AWS. This one. Oops. So this is going like this, connection towards internet, and from public subnet, we will go towards internet gateway. So we are connecting public subnet towards internet gateway, and internet gateway is moving towards internet. So to achieve this, we should add the routing table of the public subnet. So we will update over here 0.0.0.0/0 to anywhere it should refer to IG -VPC Mumbai. So to go towards internet, it should route the traffic. So that's how we are updating the routing table. And in the same way, you're going to update the routing table while implementing these network components. And where these security rules will come into picture. So when this infrastructure is created, then we will place some components like suppose when you are placing some compute into the public network. So like if we are installing some Windows Server 2019, so we will place one server in public subnet. So to access this one, some user that will be accessing it, let's place that illustration as well. So suppose these are the admin users of a company. So they will access it over the internet. Let's put the arrow. So from here, they will access this one. Sorry, start drawing. So they will come over the internet towards the AWS cloud, and through internet gateway, they will access the Windows server. So to allow this access, how you will define it, rule ID 1, protocol. So we will connect this Windows server over RDP 3389. Sorry, protocol will be RDP, port range 3389. Source anywhere from the internet can access it, /0. Destination are public subnet, PS-VPC-Mumbai. Action allow. So whosoever wants to connect this server, the admin groups, they can access it. And also, if you want to publish any website over the internet, so you can add another rule, like let me add one, insert row after, okay, rule ID 2. So if you want to allow like HTTP port 80, and here source will be PS-VPC-Mumbai. So towards internet 0.0.0.0/16, sorry, 0, action allow. So here to outside and from inside, we need to allow HTTP port from this side and also from inside. So that's how we can understand and allow different security groups on this. And for this private subnet, what we can do is we are not exposing this to internet. So we will not update the routing table for this. And also this is not directly accessible from internet. So to this, we will access from public subnet to private subnet only. So that's how we can define the rule ID 1 protocol. If we place one machine over here, Control Z. So private, one Windows machine in private. So protocol RDP, range 3389, source public subnet -VPC-Mumbai. This means we want to allow traffic from only public subnet. Destination private subnet -VPC-Mumbai. Action allow. So you might have understood like how we are creating creating these components and updating the diagram. So by creating this diagram, you will get a real picture of what you are implementing in the AWS cloud. So once we move forward while creating all these components, I'll also, if you need help how these components will be configured in the AWS cloud, I'll mention the link in the description. So you can access this link, and you can create this all infrastructure over the AWS cloud, and also create this diagram. So it's quite interesting and really easy, and a lot of benefits are there for creating the diagram. So I hope I have helped how to create interesting diagrams, and you can easily do that. So we have created this diagrams. Also, we have added the compute part, and also I have shown how you can update the rules of the virtual firewall. So you can do that easily, not a problem, and you can create this infrastructure over the cloud. So I hope I have added some new thing into your knowledge, and the benefits of the diagrams, the real thing that is conveyed from the diagram, what our benefits are there, and how it will benefit you, and how you can ensure the availability of the services. So in case you have any questions, doubts, queries, don't hesitate to ping me. Also, if you want to send your diagrams to me, I can review those as well. So that's all for this video. I hope you have enjoyed it, and definitely this will help you to learn more and more things. So thank you for watching this video. I'll create more videos in future. Thank you. Bye bye. Hello everyone. So I hope you are doing good and safe at your homes. So I hope you remember in the previous videos, I have created a series of videos in which I have given introduction about our course, which is called Journey to Cloud Technology AWS course. So in that, I have provided information about different levels and modules that are covered in the course, and like level 0, level 1, level 2, and level 3. So these are the different levels in our cloud course, that is for AWS cloud course. And also the modules that were covered, I have provided complete details what is being covered, the theoretical and practical things that we are going to covered in each module, and modules for AWS services for network, compute, storage, database, security, and AWS management services, and AWS architecture framework. Also, after that, I have discussed like AWS solution architecture. So, and customer use cases, like how customer comes in and with different requirements, and based on that, what kind of different AWS services that can be used to create a complete solution. So that will really help the students while creating a solution. So in these different use cases, we covered architectures for network, storage, compute, database, security services, and most importantly, we also covered infrastructure architecture for infrastructure as a code, which is called AWS Cloud Formation Service, and also provided introduction about AWS DevOps services, and also given insights about deploying applications in different ways on AWS as per the customer requirements.
So also in that video playlist, I have included short training videos of trainers showing how cloud concepts are clear during theoretical classes. And if you have missed that video, please do watch them and understand how cloud course is being launched and how different concepts are being cleared. So that's all for this slide. Let's move forward. So in this video, I'll cover practical labs that are covered in the AWS Cloud course, so that you can get help from this video and start playing around with AWS Cloud Console and services and see how easily one can create cloud services. So if you remember in that cloud architecture solution that I discussed in previous video, I'll continue with that, and first I'll create network layer on the AWS cloud. So let's move forward, and here is the network diagram on the next slide. Network diagram and little bit introduction about this use case. Like in this, we will create a network layer, and first we will log in into AWS Cloud Console, and I'll provide introduction about the Cloud Console and AWS services. After that, we will create virtual private cloud, VPC, and creation of internet gateway attaching it to VPC, public and private subnets, public and private routing tables to route the traffic to different networks. And then we will create AWS virtual firewalls, which is called security groups. So we will create separately for public and private security groups in the network layer. So in the next slide, I'll show you the network layer diagram. So in this is the virtual private cloud with network address 10.1.0.0/16 subnet mask. And this is the internet gateway that will be created, and it will be attached to the VPC. And then we will create public subnet with network ID 10.1.1.0/24 subnet mask, and private subnet with 10.1.2.0/24. And then we will create public route table that is routing the traffic towards internet gateway for internet access and towards local. And a private route table that's not having access to internet, that's having access to local resources only. So and then we will create public security group and private security group. So let's move forward and log into AWS Cloud Console. So let's log in into. So this is my company's own login that we created. And you can see admin has logged into our Techinforay console. So I'll also create a practical demo that how we can customize our login ID and login console. So here we can see that this is our AWS management console, and here you can see your username, and let me enable annotation. So this is the username that I logged in with, and this is the N Virginia, that's a region that I'm currently logged into, and this is AWS console and recently visited services. So let me show you a little bit more. Like these are the different services for compute, EC2, and we will create different practical videos out of it. Storage services, S3, EFS, database services, and migration while moving from on-premise to AWS cloud. And here we have network and content delivery services, VPC, CloudFront, DNS service route 53. So these are all different services of AWS cloud that we will cover most importantly the services that are there in the syllabus for solution architect associate exam level, and you will get clear idea about different AWS cloud services. Also, we will cover the different AWS solution architectures in which you will be able to identify different AWS cloud services. So let's move forward and create a network layer and create a VPC in it. So currently I'm into North Virginia region, so we can create a network layer in this region. So you can also select any region to create your VPC. There are different regions in AWS cloud, like in US, we have different regions, Africa and Asia Pacific, Canada, Europe. So these are the different regions that you can select and create your own infrastructure as per the requirement. So coming to VPC dashboard. So here, let's go to VPC and create our own VPC that we seen in our network diagram. So this is one already created one. This is default VPC. You can use this one as well, but also you can create your own VPC as well. So let's create a VPC. So let's give it a name, demo VPC. Let's create our own network that we see in the diagram 10.1.0.0/16. And very important thing, tagging. Tagging is very important so that you can identify different resources that are being created in AWS console and in your infrastructure. So by default, there is one name that is being seen. Also, we can add another tag called department. Like we are creating this for the network department, so we can just mention as network. Yeah. Create VPC. Yeah, so here you can see our VPC details. It has tenancy as default. We can change that as well. That we'll see later on. And this is the owner ID and main routing table. We will create different routing tables in this. So let's move forward and create subnets in that, in the VPC that I have shown in the network diagram. So let's create a subnet. First, we have to choose our VPC in which we need to create the subnet. So we are creating a subnet in our own VPC called demo VPC. So let's give it a name, public subnet. So 10.1.1.0/24. So name public subnet, let's add department. As network. You can give any tag as per your requirements also, but this is very important to create a tag to identify the resources. So create subnet. So you can see one public subnet. You can see over here having a public IP address, subnet range, and it's available. Let's create another private subnet. Select VPC. And let's provide name private subnet and a range that we seen in our diagram 10.1.2.0/24. Again, we can add our own tag for department. So department, let's select network, create subnet. So you can see the subnets that we created, private and public subnet. And let's create internet gateway and that we need to attach to our VPC, create internet gateway. Let's provide name demo IG internet gateway. New tag. Let's select a department. For network, create internet gateway. So you can see the internet gateway has created, but the current state of it is detached. So we have to attach this internet gateway to the VPC. So let's attach it to a VPC and select our demo VPC so that we can route traffic out of this VPC towards internet. So now you can see the state of the internet gateway as attached. So let's move forward and create route tables. So default route tables are already there, but let's create our own route table. Public route table. VPC or demo VPC. Let's add tag department as network. Create route table. Here you can see this public route table has been created. Let's create another route table for private subnet. Private route table. Select our VPC. Add the tag department network. So both the route tables are ready. We can see our own route tables, public and private route tables. And let's attach our subnets with different route tables. So we have public route table. Let's associate our subnets with these. So edit subnet association. So we are going to associate our public subnet with this route table. Save association. Okay, that's done. And for this, since we are going to route traffic of public subnet towards internet, so let's add route of this public route table towards internet. So add route towards anywhere on the internet. So here select internet gateway that we selected during creation demo IG. Save changes. So with this route, this public route table and the associated subnet, they can access internet using this internet gateway. So both the routes are active in this. So coming back to route tables. So private route table, let's associate it with private subnet, subnet association, edit subnet association, and select private subnet, save association. So in this private subnet, see if we see the routes, we have only local routes and that's active. So in this, we are not going to add route towards internet because this we want to save. We do not want to have access to internet. So like we can create database instances in this or application instances that do not require direct internet access. So our route tables are complete. Our subnets are complete. So here you can see our subnets, public and private subnet. Also, we have inserted the routes as well. So our VPC is ready with our demo VPC. So our basic infrastructure like creating networks, segregation of networks and routing, everything is in place. So let's configure our virtual firewalls for different subnets. So coming to security groups. Let's create a different virtual firewalls for different subnets. So public security group to allow access to public subnet. Select our VPC. So by default, all outbound traffic is allowed in this. So let's add inbound rule like if we need to create Windows machine or Linux machine, then we need to allow those required ports like SSH to connect to Linux machine. And coming from anywhere, we can connect to our Linux machines. And let's add another rule. If we are going to create Windows machines, then we need access to RDP. Let's access RDP from anywhere. So for public subnet, we have created it, and from internet, we can access our machines on 22 and 33894 port. Add tag, do not forget that. So in this department, network, yeah, create security group. Okay, so our security group is created now. So you can see inbound rules from source is anywhere like from internet or any other IP address, and towards that source that will be there in this security group. Outbound rules, everything is out for outgoing. So let's create another security group for private subnet. Private security group. Allow access from only from public subnet, not from anywhere else. Select our VPC. So outbound, everything is allowed from public subnet if we want to create any machine like application machine or database machine. And if we want to access those machines, we can add SSH and from our public security group. So here we will select our public security group, not from any other IP address. Add rule, add another rule for RDP to access Windows machines. Again, not from any other IP, only from our public security group. So you can see outbound is everything is allowed, but from inside, incoming from inbound rules, we have allowed access only to SSH and RDP from public security group only, not from any other IP address. So moving forward, let's create it. Add tag, department, network, create security group. So you can see our both these security groups are ready. You can give public name to this, public security group, and name to this as well, private security group. Save. So you can see our both virtual firewalls for our different subnets are ready, and our basic network infrastructure is ready, and we can deploy machines. So in this video, I'll cover network layer, and in the next video, I'll cover how we can create instances in our VPC and creation of instances in different subnets like public subnet and private subnet, and how we can connect it from our local laptops I'll show that everything in the next slide, next video. So coming to back to our slide. So this was the network diagram that we created on AWS Cloud, similarly like different subnets and security groups. So that's all for this video, and I'll come to create next video, and then we will see how to create compute layer in those different subnets. So thank you as of now, and if you have any questions, queries, doubts, please do visit our website www.techinforay.com and contact us, or you can give comments in the video. I'll reply to those comments and clear your questions, queries, and doubts. Thank you very much. See you in the next video. So in this, we are coming to create a Windows Server 2019 instance on AWS. So we will go to AWS console and create one instance and demo VPC and public subnet and attach EBS volume to the storage. And next, later on, we will add web server on that, and how we are connecting to the Windows instance. I'll show you that. So coming back to our AWS console. So let's go to EC2 instances. So coming to compute and then EC2 instances, where we can create our Windows and Linux instances. So here you can see we have different options, instance types. So I'll go through these. So coming to instance, let's create one instance of this. So we are on EC2 instance page. So here we can click on launch instance. And here we can see a list of different instances that are available, and we can launch any machine out of it. But the main thing that needs to be kept in mind is free tier eligible. For your free tier account, we need to select only instances that are mentioned as free tier, because if you select these, you will not be charged anything. In case you select any other machine, then you will be charged for that. But for practical demonstration, you can select these free tier eligible, and these are having sufficient resources. So in this, let's while we are creating Windows instance, let's create Windows Server 2019 base. This is eligible for free tier. So select this. So here you can see type of machine, family, and number of virtual CPUs in each machine, memory, instance storage type, optimization, network performance types. So as per the customer requirement, based on his requirement for performance or number of vCPU required, memory required in each instance, you can select that type of instance. So there are different instances in this. You can select any one based on the number of CPU requirements. So if we go down, the CPUs are increasing, and the RAM also. So here for our practical demonstration, let's select the T2 micro. It's having one virtual CPU and 1 gig memory, and this is sufficient for our practical demonstration. So let's move forward and configure the instance. So we are going to create only one instance, and network, let's select our demo VPC, and we are going to launch this in public subnet. Disable this because we are going to allocate elastic IP address to this instance. Let's keep everything default as of now, and we will cover those in detail in the rest of the practicals. As of now, let's keep them by default, and let's add storage. So here we are adding storage EBS volume to this instance. So as part of our practical demonstration, we are adding this volume of 30 GB to this machine. Also, we can add new volumes also, EBS types, so we can add that as well. As per the requirement, we can mention the number of size, and if we require encryption or not, and check this option also, because when you are terminating this machine, you need, this will be automatically terminated. But in case you are not checking this, then this volume will remain in the infrastructure and you will be charged for that. But don't forget to check this. So let's keep only one device. That's sufficient for our practical demonstration. Let's move forward and add tags. This is again very important. Department. Let's keep as for network as of now. Security group. So here, if you remember, we can create a new security group also, or we can select an existing security group. So we have created during our network infrastructure creation, we have created our security group. So we will select out of that. So we are placing this in public security group. So let's select that. And these are the ports that are allowed. Since we are creating Windows instance, we have allowed RDP to connect to this instance. Let's review and launch this instance. So you can review the configuration, instance details, storage, and tags, and click on launch. So here, this is also one important step. Select an existing key pair or create a new pair. If you have existing key pair, you can select that one, or if you want to create new one, I'll show you this in the practical demonstration. Let's create a new key pair. Let's provide, we are creating this in NV region, key pair 2. Let's do this. So download this key pair and keep it at the location where you remember it, because without this key pair, you will not be able to connect to this instance. So downloading it, and I'll store it in our AWS keys. So save it and click on launch instance. So with this, our instance will be launched. So if we go to view instances, so you can see our instance has been started provisioning. This will be all automatic. So you can mention over here public Windows instance, public Windows instance, save. So this is into running state, and we need to check the status for this. So once it is initialized, you can refresh this. So it's initializing now, and so once this will be ready, it will mention that it's ready to use now. So for the time being, I'll stop this video until this takes a few 1 or 2 minutes. So now we can see our public instance Windows is ready, and all the checks has been passed, and it's running now. And we can set the administrator password password for it. So click on this, and the IP address has been, this is private IP assigned to this is 10.112.212, and installed in VPC demo. You can check all these details like installed in public subnet, type of instance, and it's running, and this is the instance ID of this Windows server. And security, if you check in security, we have placed it in public security group, so you can check, and all the ports that are allowed for this machine, networking, IP address, and which subnet is its place. So you can check all these details when you click on this instance. So let's try to connect it and connect to this instance. Click on RDP client. We'll use MSTSC RDP client to this. So this is important to get the password. Click on get password and browse to the key pair that we saved. AWS key, select this key, open, and then click on decrypt password. So now you can see that you have administrator password for this. So you can copy this password and we can paste it in our notepad. So now our next step will be to allocate elastic IP address to this instance so that we can access this instance over the internet. So let's go to elastic IPs. Here we can see our demo elastic IP. So associate this elastic IP to our instance. So we have selected resource type instance. So if you click over here, so we can see our public Windows instance. Associate this IP address. Yeah. So this demo elastic IP is associated to our Windows machine. So let's go back to our instance, and here you can see public IP assigned to it, elastic IP. So let's use this IP address and connect to this machine. Let's go to RDP session, and the username we will use root/administrator. Note down one thing that you can use administrator also, but in case you are not able to connect, then use root/administrator. Then it'll allow you to connect. There are certain local problems with the laptops that allows maybe with the administrator or root/administrator. So click on connect. So let's use our password. Root/administrator password. Click OK. Yes, accept it. So it's configuring a remote session, and yeah, we are able to connect to our Windows machine. So it's doing its initial settings, and then our server Windows 2019 will be ready. And now let's minimize it so that get initialized. So if we get back to our presentation, so we have create a Windows instance and attached the storage for it, placed it in public security group, and connected Windows instance using security keys and generated administrator password. So now let's add web server role on the Windows server and publish the page over the internet. Let's configure web server on the instance. So here we are into our server. So here you can see details, also the instance ID, public IP address, private IP address, instance size. So you can see all these details on the server as well. So let's go to server administrator, server manager. Here we can add different roles on the server. So in this practical demonstration, I'll show you how we can add Windows server, Windows web server. So it takes some time for initialization. For the time being, I'll pause the recording. Okay, so here we will add role to this server. Select next, role-based feature next on this server. Select web IS server, add feature, next, next, install. So you can see that our installation is almost complete and installing of web server on Windows server. So our IS service almost ready. So let's close it and test it. So if you open Internet Explorer and we can test local page, and then we can edit the page also. HTTP localhost. Yeah, so this page shows that our internet information services are running on this local server. Let's add and customize our page and see how we can see that page, or you can put your own website over here and you can test that as well. So if we go to C inetpub www.root, so you can edit this file or you can place your own website over here and you can see that as well. So let's open this file with not Internet Explorer. Open with this notepad and we can edit it. Control A, delete. This is demo web page on Windows server. Save, close. So if we refresh this page, we can see our page that we edited over here. So this is just very small page, but you can paste your own content over here and then you can see this. So now let's try to access this page using this our public IP address on our internet. Let's see if we able to access this. So coming back to our instance. Let's add new one. Copy the public IP address, HTTP. I hope this will not open because there is a problem. So I just give you a time to understand or think what could be the reason out of it. If we go back to our diagram in the slide, you will get what could be the reason. So let me Go to our diagram. So in this diagram, we have placed our EC2 instance over in the public subnet. If we try to open it locally on HTTP port, it is allowed. But if we are going to access it over the internet, then it's not allowed. I hope we can see that practically, but just think where we need to allow that. You need to think about firewall or local instances or something like that, because I'll in the next 1 minute, I'll let you know the solution for this. So just think, pause the video and think about it where we need to allow this. So here, if we see that we need to allow the port on the firewall. So here our firewall is a public security group, and that is controlling the access from internet to our local instance. So let's get back to the public security group and check the ports that are allowed. And then we need to allow HTTP port on this instance so that we can access this page over the web. So if we go to our security group, our virtual firewall, public security group. So here you can see we have allowed only 22 and 3389 port for this instance. We haven't allowed HTTP port. So let's edit our inbound ports, add rule, HTTP. Access from anywhere, save. So now this port is allowed. If we refresh this page, accessing over the internet with the public IP address allocated to the machine, I hope this works. Yeah. So now we can access this demo web page on Windows Server, and you can see how easily we have created a web server, Windows 2019 server, and publish our web page over the internet, and how easily, how fast you can see that. And during some troubleshooting steps, do apply your mind where we are lagging, because that's required in industry. You have to troubleshoot the problem and need to understand where the problem lies and resolve that issue. So that was part of this video, and in next video we will create Linux instance, and I'll show you how to connect that, install a web server on that instance. So thank you for this time, and I'll see you in the next video. Thank you. Hello everyone, welcome back to another video for compute practical demonstration. So I hope you remember we discussed this diagram in our previous video, and we created Windows instance, and in the public subnet. So in this practical demonstration, I'll install Linux instance in the public subnet, and I'll move this elastic IP address to Linux instance and connect this Linux instance, and we will place this Linux instance in public subnet and access it over the internet. And also, as a part of this demonstration, let me get back to the slide. So in this practical demonstration for Linux instance, we will log in into AWS console, and we will create Linux instance and place it in demo VPC, and in public subnet attach EVS volume storage, and instance will be placed in public security group. And we will connect the Linux instance using security keys and generating private key. This is a bit different as compared to Windows instance. And then we will install web server and publish the page over the internet as we did in Windows server. So the main objective of this is that creating a Linux instance and how easily we can install web server and publish the page over the internet. So let's get back and go to the AWS console and create a Linux instance. So here, let's log in, open our console. Let's log in using our zadmin and password. Okay, let's go to EC2 instances and create Linux instance. So as we created Windows instance in our previous instance, public Windows instance, it's running. So let's create a Linux instance. We will select Amazon Linux 2 AMI and select it. We will select FreeTire T2 Micro with 1 CPU and 1 gig RAM. Click on Configure Instance Details. So here we are going to select again, if you remember before, demo VPC and place in public subnet. We are going to disable this as we are going to allocate elastic IP address. Add storage. Storage, we are going to attach 8 gig in this. Do not forget to check this, delete on termination. Also here we can add another volume in this Linux instance as well. So, but as a practical demonstration, we do not require it. So we are not adding it. Add tags. So similarly as we done before, department, network, configure security group. So let's select our security group, public security group. So as you see before, we have allowed these ports and SSH was already allowed, and we can connect the machine. Review the configuration over here and click launch. So we have already created our key pair over here, so we can select that NB key pair 2. I acknowledge it and launch instances. So this, if we go to view instances, so it is getting ready, and as of now it's pending status. Let's add the name, public Linux instance. Sorry. Save. So this will take some time to get initialized and to refresh this page. So it's still initializing. So if we go to Putty, I'll show you how we can use it. So before that, let's see, we can move our Elastic IP from Windows and to Linux instance. Go to Elastic IP address, which is already allocated to Windows instance. So let's associate it to Linux instance. So now you can see two machines, public Windows public instance and public Linux instance. So now we want to connect our Linux instance. So we are associating this Elastic IP to our Linux instance. Let's disassociate before associating to another instance. Disassociate. Okay. Now let's associate to Linux instance. Associate. Yeah. So now this Elastic IP is associated to our Linux instance. coming back to instances. So let's see if it is ready. It's still initializing. It takes some time to pass all the checks and get ready. So for the time, I'll pause this video. So our public Linux instance is ready, and if we see the details of this instance, so we can see our public IP, elastic IP, it is allocated to this Linux instance. So let's use this. Okay, so coming back to the diagram, guys, just an overview. So we have created our Linux instance and placed it in the public subnet, and we have moved our elastic IP to the Linux instance. So let's try to connect to our instance, and so going back to, so this next step is a bit important, like generating private key. And let's go to puttigen and load our key that was used during creating the instance. So we used kpnv to open it. Okay, so save the private key. Yes. So kpnv to private key. So it will be saved as a .ppk save. Okay, so we have saved our private key, and let's go to the console and copy the public IP, elastic IP that is assigned to this, and open putty. Paste it. Now go to SSH on auth, browse the private key that was generated. Click on this, open, and then click open the connection. So here use EC2-user as a user. So it got authenticated now using our private key. So here we can work on it. So let's get into sudo su user super user and install all the updates. This is also important step to update all the pending things that were there. So update the machines with all the required softwares. Yes. So it takes some time to install all the required softwares on the that are important and update the existing ones as well. It also installs the AWS the shell also command line interface that we can use it. So here all are ready. So if you see AWS version, so see all these are the different command lines that we can use in AWS. So AWS command line is also installed. So you can use it if you want to configure all the infrastructure using these commands. So we will use commands in the later classes. So let's add web server on this. I have copied the commands in the notepad. You can use these commands and just copy paste it so that we can save some of our time. So install web server on this, HTTPD, and check config. Okay, start our service. Start, and let's rename the file. That is the default file. We want to create our own page. Okay, let's create a test page using HTML. This is test page on Linux instance. Okay, we are creating it. Restart the HTTP server. Okay, so our next step is we have already copy our public IP address and open it in the console. So using this, open it HTTP. We have already allowed HTTP port in our previous video. You can see that in our security group. So yes, our Linux instance web server is working. So this is a test page that we are accessing. So see how easily we can create a web server and publish it over the web, and we can access it. So that's all for this video, and we created a Linux instance and placed it. And let's get back to our diagram. So placed our just overview what we did in this video. We created Linux instance and moved the elastic IP to this one and accessing it, publishing the web page as we discussed in our previous video. Moving to previous video, just what we did. So what we did is we created a Linux instance, and then we created the Linux instance in the demo VPC, and attached EBS creation, EBS instances behind the security group, and we connected it using the generating the private keys. I have shown you in the video how to generate the private key out of our key pair, and then we installed the web server and published the web page over the internet. Also, we covered the tags that I shown that I was creating in all the videos, like all the components that we were creating. We were using department tag and using network. So I have shown in the video that how we can see all the components that were tagged to this network, and from there we can see how all the components are created in our AWS infrastructure. So that was all for current video, and we can in our next videos what we can do is since we have created these two instances. So in next video what I'll do is we have two instances, and we will install a load balancer over here and balance the traffic out of it to all these instances and access the traffic using this load balancer DNS name. So this DNS will segregate the traffic on these instances. Then what we do is if load balancer is moving all this traffic to these devices, this one instance, then we will put this instance to stop stage. Automatically load balancer will start moving the traffic to another instance. So we already have web server on these both instances I have shown in your previous video. So we will add load balancer in the next video. And that's also industry level use case. You will understand how load balancer works and how we can create that in the AWS instance. So thank you for this video, and I'll see you in the next video. Thank you very much. Hello everyone, I hope you are doing good and safe at your homes. So Techinforay has come up again with another video and practicals. So this time I'll add compute layer. So let's run through the slide, and this is a part of the Journey to Cloud Technology AWS Cloud course. And for this cloud course, I have provided introduction in my previous videos. So if you want to have a look at those videos, you can watch those videos and understand about this course. So let's move to next slide. So this was the high level of that course, and I have explained in detail about the course in my previous videos about different modules and different use cases that are included in this course and different levels in which we have designed this course. So I'll not explain this in this video. You can watch previous video if you want in detail information about the cloud course. So in my previous video, we discussed about network, and in this we will discuss about compute practical demonstration. I hope you remember that in use case one, we created network layer and we created VPC and the creation of internet gateway and attaching it to VPC and creation of subnets, routing tables, and security groups. And I hope you remember this was the diagram: creation of different public subnets, route tables, and security groups. So I hope you remember this one. And in this same network, we will launch our compute layer. So moving to the use case for compute layer. So this is the use case, like when I'll continue with the same use case that we discussed initially, that whenever a new customer comes up, he creates a network, compute, storage, database. These are the main components of the solution. So we have covered basic network architecture, and now we will add compute layer in this. So in this compute, I'll log into AWS Cloud Console, and then also introduce you about the allocation of elastic IP address. This is also quite important concept. And then we will create one Windows Server 2019 instance and add web server role on the server and publish the web page over internet. And see you will find out that how easily we can create a web server and how easily we can publish the page over the internet. And also we will create a Linux instance and install web server on Linux instance and publish it over the internet. So there are different ways of connecting to Windows and Linux instances. So I'll show you those in the practical demonstration. So let's first see how we can allocate elastic IP address. So we will log in into AWS console and go to EC2 instances, then elastic IP address. Then we will allocate one IP address from the Amazon pool, public IP address. And this elastic IP address can be associated with instances to access the instance over the internet. So, and in second one, we will create Windows server and then Linux instance. So if you want to see, this is the diagram that we will come up. So that was the previous network architecture, and in this we will install one Linux instance and one Windows instance, and another Windows instance in private subnet. Then we will access this Windows server from our public Windows server, so that because this private subnet, if you remember, is not having access to internet access, so we cannot access this private subnet directly. So this is another layer of security where we are segregating the networks from external internet. And about public elastic IP address. So in this, we will allocate one public elastic IP address, and we will allocate to different instances, and then allocate to different Linux instance and access it over the internet. So this is also quite important concept of elastic IP address. You will understand it practically. So that was all for the theoretically, and let's move to let's log into AWS console, and let's get back to our first practical of creation of allocation of elastic IP address. So this is our Techinforay login console. So if you remember, this is the username, and these are the different regions, and we have logged into North Virginia, US East 1. So I'll go to the VPC and show you the different VPC and subnets that were created as a part of network layer. and then I'll allocate one IP address, elastic IP address in this. So if you come to VPCs, here are the VPCs. One is default and another is that we created as a part of yesterday demo VPC that was created 10.100/16. So if you want to detail how to create it, you can watch my previous videos, how to configure VPC, subnets, route tables, internet gateways. So let's go to Elastic IP as a part of this practical demonstration. So coming to Elastic IP, so you can browse it through VPC also, as well as from EC2 instances. So come to VPC and then you can go to Elastic IPs. So here we are into Elastic IPs. So we will allocate one Elastic IP address. So this is the zone network border group, US East 1. And in this, let's add tag that's quite important, department that we created yesterday, network. So allocate. So this is the public IP, Elastic public IP that is allocated to us. So this is demo Elastic IP. So the main, the important thing is that if you allocate Elastic IP, use this, because from pricing perspective, if you are not using this public IP and you are allocating it to yourself, then you are being charged. And also when practical demonstration is over, or you are done with your practical, then release the Elastic IP address. Don't keep it with you, else you will be charged for this if you are not using it. So here, once we are creating instances, then we will associate this Elastic IP address to that instance, and then we will access it over the internet. So this is how you can allocate Elastic IP address to different instances. So if we click on associate Elastic IP address, so here we can select the instance network interface, and when we create our instances, it will show up here, and then we will associate our Elastic IP address. As of now, we haven't created it, so we cannot see those instances. So let's go back, and this is our Elastic IP. So let's go back to presentation, and so this was the presentation of creating Elastic IP address, and hello everyone. I hope you are doing good, and Techinforay is there with another video to clear your practical concepts. So here in this video, I'll show you how to create a load balancer and balance the loads on different instances. So I hope you have, you remember in my previous video, we created Linux and Windows instances with web server on that. So so in this video, what we do is we already have Windows and Linux instance in our web server, in our demo VPC and public subnet. So in this, we will create a target group for load balancer, where load balancer will shift the traffic and add those Windows instance and Linux instance in the target group and create a load balancer. Then we will access the web pages that is installed on Windows Server and Linux instance using load balancer DNS. So load balancer will start diverting the traffic on these instances like this. So once we are done with this, then we will, just for testing purpose, what we can do is we will stop one instance on which existing traffic is going, and then automatically load balancer will shift the traffic on another instance. So let me go to the diagram for more clarity to show you. So I hope you remember this diagram that we created in our previous, used the same diagram in our previous practical videos. We created network layer, compute layer, and we have public subnet, private subnet. These are the routing tables and security groups, public and private security groups. So you can watch previous videos to how to create all these different components. In this video, what we are going to do is we have existing Windows instance, Linux instance with web server installed it. And in this video, we will create a network load balancer and balance the traffic on these instances for their web traffic. So this is also another industrial use case where load balancer is used for segregating, for sending the traffic on a group of instances or group of web servers. So we can say this is our web layer, as we discussed our use cases in our while discussing the AWS security architectures. So there we have seen that this is one of way using deploying application using network load balancer. So let's log into our web console and create a load balancer. So here we already have, as I described, I created a Windows instance and public instance. So here and web server is already running, and we tested this in our previous video. So in detail, if you want to check how to create a Windows instance, Linux instance, installing web server on these, so you can check those previous videos. So without wasting time, let's get into load balancer practical. So let's go to VPC. So we are in North Virginia using our username Techinforay at zadmin. So zadmin is a user in Techinforay. So let's go to load balancer. So here we are into our console. This is our VPC. Let's go to EC2 instances for creating a load balancer and target group, as I shown you in the diagram. So here is load balancing group. So let's go to target group and create the target group and add those instances in it. So click on create target group. We are creating a target type instances. Target group is demo target group. So protocol, we are going to use TCP and our own demo VPC. Health check, we are going to use HTTP, and this is the way how it is going to check the health. So here are some more health checking settings. Let's keep default for the time being. And if you want to see all those theoretical concepts, you need to go to our AWS Cloud course, and there you can see how all these things working in theoretically. So here I am covering practical concepts only. So click on next. So here are instances that we created. Let's choose these public instances on which we have enabled web server, include them into our target group. So create target group. So this is our target group, and this for the time being it is showing as unused. So let's create a load balancer. So click on create load balancer. We are going to use network load balancer. Create demo LB internet facing, and select a VPC or demo VPC and US East region. It is accepting on 80 port, TCP 80. Select our target group, demo target group. We have added the listener on which traffic will be, on which load balancer will throw the traffic. So these are the default things. Tags, we can add tag, department, network. Okay, create load balancer. Okay, we need to select this public subnet, create load balancer. So click on view load balancers. So this will take some time. It's provisioning, and this is the DNS name that is generated for this load balancer. So we will use this DNS name to access the web servers that are installed, web pages that are installed on the instances, and this is internet facing. So this will take some time. So for the time being, I'll pause this video. Okay, so you can see that our load balancer is ready and it's active state. So if we go to our target group, demo target group, so you can see our both the instances are healthy, and load balancer has performed the health check on both these instances, and this is healthy. So now if we go to our load balancer and copy the DNS name, and let's go to our Explorer. So if we paste our DNS name for load balancer, so now we can see to which instance it is throwing the traffic. Yeah, so it is throwing the traffic on Windows instance. So now what we can do is now you can see that we are accessing the web pages of those Windows instances through the load balancer. I'll show you on the diagram. So these are our web servers. These are our web servers. First, we were accessing these web servers using their own public IPs. Now we have placed load balancer before these instances, and we are accessing these web pages using this load balancer. So I hope this clarify the concept. So now what we are going to do is, so now the traffic is going towards a Windows instance. We will stop this instance. Automatically traffic will move towards this instance. Let's go to our console and do that. So this is going towards Windows instance. Let's go to our console. Let's go to instances, EC2 instance. Let's stop our Windows public instance, and it will show unhealthy in the target group once we stop it. But it will take some time because there are some settings in the health check system. So stop this instance, stop. So it is getting stopped. So if we go to our target group, there we can see this, the state will start changing after some time. So now health check takes some time. We have defined these settings. So we have stopped the Windows server. So if we go to our load balancer, so if we refresh it, so this will throw the traffic on Linux instance. See, this is a test page on Linux instance. So I hope you understand the concept now. Automatically, web server, Windows web server is stopped and traffic is going on Linux web server. So this we have shown a automatic failover of the traffic. If one instance goes down or something wrong happens on one instance, automatically another instance is ready to take the traffic. So this is a concept of load balancing. And if we go over here, so this after some time, this will turn, our Windows instance will turn unhealthy. Let's refresh it. Yeah, so now you can see that our Windows public instance is unhealthy because we have stopped it, or maybe in real scenario, there could something wrong happens on the web server, it goes unhealthy and traffic is going to Linux instance. So that was all for this video. Our main objective was to show the working of load balancer, load balancing the traffic to different instances. So thank you for watching the videos. In case you have any questions, queries, or doubts, do contact us on website techinforay.com. Thank you very much. Hello, everyone. I hope you are doing good and safe at your homes. So Techinforay is there with another video. And in this use case, what we are going to describe is, as we discussed in our previous diagrams, that we are going to create a instance and private subnet. And but for important updates, we need to enable a secure internet access for one side only. So in this, that's what we are going to do, is that we are going to create a NAT gateway, and then we are going to enable create one instance in VPC or demo VPC and in private subnet with no internet access. Then we will access our public Windows instance from internet and access this private Windows instance, and we'll see there is no internet access. But then in the next step, we will create a NAT gateway and update the routing table for this. So let me come to diagram for more clarity. I'll show you. So if we come to our diagram, so here we can see that this instance will be created in private subnet 10.1.2.0, and we will access from internet to this instance, and then we will, from here in this Windows instance, we will access this instance, and we will check on this instance, there is no internet access. But we will install our NAT gateway and then update the routing table with the NAT gateway root, and then this can access through this secure internet from the NAT gateway. So that's another use case where you may require, or where a customer requires that they want internet access on private subnet in a secure way. So through NAT gateway, we can enable that internet access. So let's log into our, let's go to our AWS console and create one Windows machine in private network and access it from our public Windows instance, and then we can see. So, and we will create NAT gateway. Okay, moving to our AWS Cloud Console. So here we are into our instances that we were created in our previous practicals. So let's launch instance in our private network, and let's create Windows. So we will select again free tier eligible because there are no charges for this. Select our demo VPC. So here we are selecting our private subnet. Add storage, add tags, add tag, department, network, configure security group. So in this, again, we will place this in our private security group. So as we created this security group, that this security group will be having access from only our private security group, from not any other IP address or something like that. So we have enabled RDP 3389 from our security public security group to this private security group. So review and launch. Launch. We are using our existing key pair. Launch. So let's go to view instances. So let's change the name. Private Windows instance. Private Windows. Sorry. Private Windows instance. Instance. I don't know what's happening. Maybe I'm clicking somewhere wrong. Private Windows instance. Save. So it will take some time. For the time being, let's pause. Let me pause the video. I'll enable it once this instance is ready. Okay, so our private Windows instance is ready. So if we go and check the details, there is no public IP address on this, and our private subnet is 10.1.2.219, and private subnet is this instance is in private subnet in demo VPC. So in networking, if we see that enabled in security group. So in security group, we can see this is allowed from, and this is in private security group and only allowed from public security groups. So you can see that, yeah. Okay, let's connect to this instance. I have connected to this public instance on this elastic IP that we allocated it. And I have created the password for this private instance also. How to create the password, you can watch our previous video that how to create the password. I have mentioned complete details in the previous video. So in this video, let's connect to our public Windows instance, then we will connect to this. Let's copy its private IP. I have connected to this public Windows instance that is our having elastic IP address in subnet 10.1.194. That's our public instance. So in this, let's connect to MSTSC. MSTSC. RDP connect. Yeah. So our username is administrator. Password, I have already created it. Let me copy password. Control C. Paste it. Okay. So now we are connecting to our private instance from public instance. In case you are confused with the connectivity, you can check the diagram. So for clarity, you can see over here on the just rewind the video, you can have more clarity on the diagram if you get any confusion how the network diagram is. So our private instance is getting ready 10.1.2.219. So if we open Internet Explorer on this, then we can see there is no internet access on this. So if we open Google, google.com. Yeah, so you can see that this keep on revolving. So there is no internet access on this. Let's add this, add, close. This is a local Windows setting. So this can't reach to internet. So let's get back to our AWS console and create a NAT gateway. So for NAT gateway, we need one more elastic IP. So allocate elastic IP for NAT gateway, allocate. So we have allocated two IPs. Let's allocate this elastic IP for NAT gateway. Please do not forget to remove these IPs, else you will be charged for these. So coming to our VPC, we need to create a NAT gateway. Then we will allocate this elastic IP to the NAT gateway. VPC. So here, let's click on NAT gateway, create NAT gateway, demo NAT gateway, subnet, public subnet, and associate elastic IP address, elastic IP for NAT gateway that we created there, and add tag, department, network, create NAT gateway. Okay, so our NAT gateway is ready, state is pending. It will take some time to get ready. So for the time being, let's update the routing table and put the routing table, private routing table towards NAT gateway. So here is our private route table. So let's edit the routes and add route 00 towards NAT gateway. So this is our demo NAT gateway. So we have updated the routes. So now this will give, so this private subnet will go towards NAT gateway for internet access. So let's see our NAT gateway is ready. It's in pending state. This will take some time for getting enabled. So for the timing, let me pause the video until this is ready. Okay, so our demo NAT gateway is available now, and this will be used by a private instance. So let's go to our private instance and check if internet is working on it. Google.com. Yes. Okay. Add, close. Yeah, you can see that now internet access is working on it. So that was our practical demonstration for this video, that how we can enable internet access on our private instance. So this is our private instance 10.112.19. So that's how we can enable internet access using NAT gateway. That was our use case. So if once again I'll show you the network. So this was the network that I created, private subnet. Let me enable annotation. So private subnet, we created NAT gateway, also added elastic IP to this. So you know that how we can add the elastic IP to NAT gateway. And now for internet access, this is going like this. Also, we updated our routing table, private routing table. Before it was like this. So we added one more route 00 towards NAT gateway. So I hope you understand the concept of creating a NAT gateway and enabling internet access on the private instances. So I hope you will understand, and that it will be helpful for understanding for all the complete theory for NAT gateway and all the compute layer. You can see our theoretical classes and see the AWS Cloud course details that we discussed in our previous videos. So thank you for watching this video. See you in another video. Thank you. Hello, everyone. I hope you are doing good and you are safe at your homes. So Techinforay is back with another set of practical video. And I hope these videos are helpful for clearing your concepts related to different AWS services. So in this video, we will discuss about VPC peering connection, and I'll discuss a few use cases also that are dependent on VPC peer connection. So just a background, what I covered in my previous videos, I have created videos on different like creating a network layer and then adding elastic IP demonstration. And then we added compute layer and NAT gateway concept also. And another concept, interesting concept of load balancing, that is distributing the uh, internet traffic to different instances. And then I also created another beautiful concept of auto scaling group. And I must recommend to see these videos and you can understand these concepts. So in this video, I'll work on VPC peer connection in same region and different region. So let's move forward and create this concept and on AWS console. So VPC peering connection. So if we talk about this concept, it's about like establishing connectivity using AWS Transit Gateway or VPC peering connection. So these are two different concepts of Transit Gateway and VPC peering connection. So I'll cover both of these Transit Gateway and VPC peering concept in these coming videos. So in this, I am talking about VPC peering. So it's about connecting different VPCs, that is virtual private clouds on AWS, and establishing communication between two VPCs. So if we talk about VPC, it's like a virtual data center that we are creating on AWS. So in case like if there are two customers and in same region or in different regions of the world, and they want to establish communication between these two VPCs, so we can use VPC peering connection. Or another use case can be like customer A wants to establish connectivity between customer B network and like providing services like POC or some other services that needs to be provided to customer B, and they require communication between their different VPCs. So to enable that, we need to use VPC peering connection. Or another use case can be like customer A has overtaken business of another customer B, and now they want to establish a communication between these two networks or different virtual data centers between two VPCs. So in that case also we need to use a VPC peering connection. So if we see diagrammatically, what I'll cover in this video is that these are two VPCs in the same region, region 1 and region 1. So, and these are two VPCs of customer A and customer B. Customer A is having VPC 1 and VPC 2. And then we will select VPC peering connection to establish communication between these two connections. These two virtual private clouds or virtual data centers. What I have done is I have already created VPC1 and VPC2 and already created public subnet and launched a Linux machine in this public subnet, and also launched another machine in public subnet of VPC2. And we will create this virtual peering connection and VPC peering connection to establish communication between these two VPCs. So let's go to AWS console and check the practical concept. So here I am into AWS console. So if we talk about region, I am into Mumbai region and located in India. So as I've shown in the diagrammatically, I have created two VPCs, and this is VPC1 with network 10.100/24 and another VPC2 that is 10.11.0/24. So I have created these two VPCs, and if we see move forward and subnets, so these are the two subnets, VPC1, public subnet for VPC1 and public subnet for VPC2. So these are the subnets that I have created it. So moving forward and route tables. So if you want to see how I created these VPCs and subnets, you can visit my previous videos and watch those, and that will be helpful for creating these different network services components. So these are the routing tables for VPC1 and VPC2. And I have created separate gateways for VPC1 and VPC2 so that when we launch machines in that, they can access internet, and accordingly have updated their gateways also in the routing table. So this is the if we talk about routing table of VPC1, then for internet connection, it's going over the cloud, over the internet gateway that is attached to this VPC. So for internet, it's going over, right? So this is the routing table, internet gateway. So these were the basic network components. So let's go to peering connection. So to establish connectivity between these two virtual private clouds or virtual data centers that are in the same region. So let's go to peering connection and create peering connection. So let's give this demo PC001. So the requester is VPC1. So VPC1, and it's in the same region, or I'll create another video for connecting to another region. So VPC acceptor is VPC2, and subnet is associated for that. So create peering connection. Okay. So we have to accept it because VPC1 has requested it to connect to VPC2. So let's select it and accept this request. Yes. So now this request has been accepted by VPC2, and we have to modify the routing tables because for these, if we see the diagram, so for this was already going to internet, but if we want to reach to this network, we have to define the route. It was going to internet like this, and this all is also going to internet. But if you want to route the traffic of this subnet towards this one, then we have to update the routing table of this subnet towards this peering connection and update the routing table of this towards the peering connection to reach to this network and vice versa. So if you understand the routing concepts, if you do not understand that, you can watch my previous videos. That will be helpful to understand these routing concepts. So let's get back to the console. So let's modify the routing tables. So if we talk about modifying the VPC1 route table, so if we go to VPCs, so for VPC, we have to add route for VPC2 network. So we go to this one, edit the routes, add route. So for 10.1.1.0/24. So that's it. So if we confirm it, so VPC2 is 10.1.1.0/24. So for this, it should go to the peering connection. So we are selecting the peering connection that we created. Save changes. Similarly, let's update the routing table of VPC2. Edit routes, add route. So just to confirm the IP address subnet of VPC1 10.1.0.0.24, 10.1.1.0/24. It should go to the peering connection. Yeah, demo PCs 0001, save changes. Is equal to more specific than the root target interface. Cancel. Edit. So the VPC1 is 10.1.0.0. 10.1.0.0/24. It should go to the peering connection. Save changes. Yeah. So now routing tables are updated and routing is established. So let's check. So I have launched two machines. If we talk about instances, I have launched these two instances in different VCs. So these are the two instances that I've launched in these VPC. So if you want to understand how the launch instances are launched and how to connect that, you can watch my previous videos. So VPC1 instance and VPC2 instance. So I have connected to these. So let's go to the instance. So this is my instance. So if we talk about subnet, VPC1 machine 10.1.1.112. So I have two machines. So this is a VPC1 machine. And if we go to another instance, 10.1.1.2.3.4. So this is the another machine. Okay. So let's get back to, so these are the two machines. So from VPC1 machine, if I ping this machine, we should be able to reach it. Ping 10.1.1.234. Yeah, so it's working. So we are able to reach from VPC1 to VPC2. So we can check this connectivity from here also. 1.0.112. Yeah. So you can see we have established the connectivity between VPC1 and VPC2 over peering connection. So I hope that was easy and understand the concept of VPC peering connection. So I hope this is helpful for understanding the VPC peering connection concept. So that was it for this video, and I hope this is helpful, and that's it for this video. Thank you for watching this video, and if you like this video, like it, and you can subscribe to my channel. I'll keep on adding these interesting videos. Thank you. Bye bye. Hello everyone. I hope you are doing good and safe at your homes. So Techinforay is back again with another technical video to impart knowledge to students and cloud learners. So this time we are trying to create more awareness on network technologies that are there in the AWS cloud. Also, we have launched AWS cloud course, and we are covering all these concepts in the course as well. So if you have any requirement for training, you can contact us and we can discuss about the training. But also as a part of knowledge sharing, you can watch these videos to get more knowledge and clear your concepts as well. So moving forward, so as a part of cloud services and demonstration network and compute practical demo, I have created this video to cover network service. So in my previous videos, I have covered AWS network layer components like routing, creation of subnets, internet gateway, concept related to elastic IP, NAT gateway, and in case a customer want to establish communication between two virtual data centers or VPCs in the same region. So I have explained that using VPC peering connection. And also if a customer is having more than 2 or 3 VPCs or virtual data centers, so they can use AWS Transit Gateway concept to connect the virtual data centers or VPCs and establish the communication between these two data centers. So that was quite interesting concepts. And as a part of compute layer component, I have created videos related to creation of Windows and Linux instances, and also enabled load balancing in front of the instances, and another beautiful concept called a auto scaling group. So where you can learn like automation in the cloud, and also load balancing, the creation of automatic AWS EC2 instances as per the load, and scale in and scale out policy. So you can watch these videos to learn the auto scaling group, and it's really good and impressive to learn automation in the cloud. So moving forward, so in this video, I'm going to cover VPC peering connection in different region. Like there is a certain difference when customer is going to establish communication in the same region and in different region. So if a customer want to establish communication in same region, I have created separate video for that. And in this video, I'm going to establish connectivity using VPC peering between customer cloud networks in different regions, or customer want to establish connectivity to another customer virtual data center or VPC in the AWS cloud in another region. So similarly, the use cases can be like customer having two networks in different regions and they want to enable communication between these two networks, or customer A want to establish communication with customer B in different region like in Asia, and another is in UK or in US. So they can establish communication using this VPC peering connection. So like these are the different components in region 1 and region 2. And we need to create like VPC peering is a regional service, so we have to create separate VPC peering connections for each region and then establish communication between them. So this is how you can establish communication and In this demonstration, I'm going to establish one region 1 and create VPC in that, and also create one instance in that, and I'll also go to region 2 and I'll create VPC in that for customer B and create one instance also. So I'll create VPC connection between these two regions to establish the communication, and then we will ping from this instance to this instance and see whether we will be able to achieve this connectivity or not. So this will be quite interesting, like if a customer is having less number of VPCs and they can use VPC peering connection. In case a customer is having more than 2 or 3 VPCs and they want to establish communication between these two, then VPC peering connection is not a good option. It creates a lot of complexity, and then they have to move to transit gateway. And I'll cover that VPC transit gateway concept in another video. So as a part of this video, I'm going to cover VPC peering connection to establish communication between two virtual data centers or VPCs in different region. So that was, I hope you have uh, got the idea what we are trying to achieve. In case you want to understand how to create instances, how to create VPCs, all those basic components, because I'm not going to cover all those things in this video, you can watch my previous videos in that, and you can learn all these creation of basic components for network and for compute. So you can watch these videos and understand how you can launch those instances and create different servers for Windows and Linux. So in this, as a part of connectivity, we are going to cover VPC peering connection, different region only. So let's go to AWS console and see how practically we are going to establish the communication between these two. Okay, guys, so I'm into my AWS console. So as I have shown on the diagram that I'll connect two different virtual private clouds, VPCs, and that are in different regions. So here you can see that I am into different region. I'm into North Virginia, and I have launched one machine, Linux machine in North Virginia, and we will connect this region using VPC peering connection with another machine in Mumbai region. So this is one, and let me go to another region. So this is my another region into Mumbai. So let's go to EC2 instances. So here I have launched two different instances in two different VPCs in the same region. So in my previous video, I have shown that how we can connect a VPC in the same region. And now we will, I'll show you that how we can connect instances in different regions. So this is Mumbai region, and another is in North Virginia. So these are two machines in Mumbai, and that's in North Virginia. So let's create a VPC peering connection and then try to ping these machines. So these are different regions in India and US. So let's create a VPC peering connection from Mumbai, and we can connect it into North Virginia. So let's go to VPC. VPC peering connection. So let's create new peering connection. Mumbai, North Virginia, PC peering connection. Okay. So the requester is we will request from VPC1 and another region, VPC2 in NV. So here I'll paste the ID. So let's move go to the console of North Virginia. So let me go to VPC, and from there I'll copy the ID of that VPC. So now I'm into NV. So let's go to VPC. So we will connect to VPC NV So let's copy the VPC ID. Let's go back to this one, Mumbai, paste it, create peering connection. Okay. So request has been initiated from Mumbai, and then let's go to, so this is my request that I have created right now. These are some of the previous I created for testing. So from Mumbai, using VPC1, I have initiated the request towards North Virginia VPC. So let's go to North Virginia, and there we will accept the request. Let's go to peering connections. So here, this is the request that was raised from Mumbai. So let's accept it. Accept request. Yes. Close. So now we can see that it's active now, and on the Mumbai side also, if we refresh this, so it's active now. So our VPC peering connection between two different regions is active. So let's update the routing tables. So I'm on to Mumbai. So let's go to routing table. So routing table public, I have placed my machine in public subnet. So let's edit the routes, add route. So my network on North Virginia side is, let's go to VPC. So 10.3.0/16. So it's 10.3.0.0/16. So let me select peering connection. So Mumbai and the peering connection save changes. And similarly on the North Virginia side, route tables. Let me update the route table. Edit routes. Add route. So let's check the VPC on Mumbai side. So VPC we are trying to connect this 10.1.0.0/16. So let's update the route table 10.1.0.0/16. Select the peering connection. Similarly, save changes. So now we will be able to connect both the machines from, we will be able to ping from North Virginia to Mumbai. So let's connect one machine in North Virginia, EC2, instances. So let's allocate one elastic IP to this machine. Associate elastic IP to my running machine associate. So now we can connect this machine, and let's go to putty. Select the private key NV. So if you want to see that how we are connecting in detail about Linux machine, you can check my previous video. I have shown in detail that how to generate private key for Linux machine and connecting it. So here we are concentrating on another practical. So here I am not covering that. So if you want to check that, you can see that my previous video, how to generate private key and connect the Linux instance. So this is the instance in North Virginia. So let's go to Mumbai. So EC2 instances. So if I check the instance in VPC1, so this is VPC2 instance. We are connecting with VPC1. So this is the instance in VPC1. I have already allocated elastic IP. So let's connect this. New session. Select the private key. Open EC2-user. So this is my Mumbai, and this is my North Virginia. So just let me point out. Mumbai, and this is my NB. So if we ping from here, we should be able to reach, and from here we should be able to reach. So let's try to ping the machine. So we will ping this one, this IP. This is the IP, private IP address of machine in North Virginia, and this is the private IP address of machine in Mumbai. So from Mumbai, let's ping the private IP of machine in North Virginia, 10.3.1.187. Yes, we are able to reach. And from North Virginia, let's ping the machine in Mumbai, 112. Yeah. So that's a successful demonstration of VPC peering connection from North Virginia to Mumbai. So this was the demos connecting different virtual private cloud or connecting different VPCs or virtual data centers over the cloud, and as per the use cases that we discussed in the diagrams. So that was it. So I hope you have enjoyed the demonstration and clarified your concept of using VPC peering connection to establish connectivity between two different uh, data centers over the cloud in different regions. So that's a main objective of demonstration. So if you like the video, then please like it and subscribe my YouTube channel for more exciting AWS cloud concepts clarification. And in case you have any queries or doubts, you can contact me on my YouTube channel and you can paste your comments over there. Thank you for watching. Hello, everyone. So I hope you are good and fine at your homes. And so Techinforay is back with another video to clear cloud concepts related to practical videos. So in my previous videos, I have covered various use cases and accordingly created the different videos. So like in my previous videos, I have created a network layer practicals, elastic IP, compute, NAT gateway, load balancer, and another beautiful and very interesting auto scaling group concept. So if you want to see automation in a cloud, you can see this video. It's quite interesting concepts. And also when we want to establish communication between two VPCs, so I have created another video for VPC peer connection in the same region, and I'll create another video for different region as well. So here in this video, I'll make you aware about the transit gateway in the same region. I'll make you aware about the problem that we face with peer connection and how transit gateway solve that problem. So let's move forward and I'll clarify this concept. So this was the peering connection video that I created before. So it was a communication, and there are different use cases like two customers want to connect their virtual private clouds or virtual data centers. So we are using a VPC peering connection. So what the problem arises is, so let's move to next video, next slide. So here we have similar use cases, but the problem comes is that when we have more than one VPCs and a customer is having more than one or want to establish communication with more than one customers, and if we need to create a VPC peer connection, what it is. So if we talk about VPC peer connection, then we have to create a VPC peer connection between this one VPC peer connection between these two VPCs, second, and VPC peer connection between this third VPC. So the problem is with VPC peer connection is that as the number of VPCs grows, we have to create those number of VPC peering connections. To solve this problem and to remove this complexity of managing different VPC peering connections, then we have a transit gateway. So transit gateway comes into a picture like when we have different VPCs, VPC1, VPC2, VPC3, or customer A, customer B, and customer C. So here in this case, what we need to do is that we are creating a transit gateway and establishing the communication between all these VPCs, creating a common transit gateway and attaching all these VPCs to this transit gateway and establishing the communication. So in this practical, I have created machines in these two VPCs. And this was the illustration that how this transit gateway helps in removing the complexity that gets created to VPC peering connection in case of more than one or more than two VPCs, because as the number of VPCs grow, then we have to create more than more and more VPC peering connections. So that was the explanation why we need to move to transit gateway and how it helps to remove that complexity. So I hope the concept is clear between AWS Transit Gateway and VPC peering connection. So, but the main objective of these two concepts is same, that we are establishing connectivity between two VPCs, between two virtual data centers, or more than one customer, or they are overtaking the customer business of another customer. And we are establishing connectivity, enabling connectivity between these two customers. So that was the basic concept, but main thing is that we are removing the complexity that gets created if the number of VPCs increase. So let's move forward and see practically how we are resolving this problem and creating a transit gateway. So if we go to our AWS console, so as we have seen in the and diagram, I have already created this VPC, VPC1 and VPC2 to illustrate and establish communication using the transit gateway. So these are the two VPCs, VPC2, VPC1, and these are the networks. Okay. So and similarly, there are the subnets also for different VPCs. Subnet, public subnet for VPC1, VPC2, and routing tables. So these are the routing tables for VPC1 and VPC2. Similarly, I have two separate internet gateways for VPC1 and VPC2, so that the machines that are installed in the VPC, they can have access to internet. So let's move forward and create our transit gateway. So here we are into transit gateways. So let's create transit gateway. So demo TG 003, allow communication between VPCs. Okay. So let's keep these default settings. So these settings are like to it automatically adds the routing table, and so if we are using this setting, it will automatically add the routing table and automatically add the propagations in the transit gateway setting. So it helps to establish the communication. So that's the main purpose. So let's keep this settings as default. Create transit gateway, close. So it's creating a transit gateway, and it will take some time. Okay, so our transit gateway is available now. So let's create the attachments. So create transit gateway attachment. So here we will select the transit gateway that we have created. And so here we are creating an attachment for VPC, enabling a communication between two VPCs. Also, we can create a attachment with VPN, like when we are establishing communication on premises, so we will use VPN type of attachment, and peering connection when we are establishing a connection between two transit gateways in different regions, and connect while establishing on the direct connect. So these are the different type of attachments that we can create on the transit gateway, and leverage transit gateway to establish communications between different connections and achieve the connectivity types. So here we are using VPC. So let's select the VPC. So VPC1. So it has automatically selected the subnet that is there in that. Create attachment, close, and create another attachment for another VPC. So let's select our transit gateway type of attachment, VPC. Let's select VPC2, create attachment, close. So it will take some time to when these attachments get available. Okay, so our attachments are ready, and that attachment is there. So these are the different attachments that we created, and so you can see we have VPC IDs. So if we talk about 66919, so it's VPC2 attachment. So we can update it for our records. VPC2 attachment. And this is VPC1 attachment, just for records. So if we see now, let's go to the transit gateway route table. So if it automatically gets created, and important thing is associations. So these are the associations that are there in with this transit gateway that gets created automatically. So this is again the VPC2 and VPC1 resource IDs that are getting attached. And if we go to the route tables, so again, these get automatically propagated. So this is our route VPC2 route and subnet gateway. Sorry, subnet, public subnet for VPC2 and public subnet for VPC1. So still one more thing that is pending is that we need to update the routing tables for our subnets. So let's go to the route tables and update the routing table. That for that particular subnet we have to go through this transit gateway. So let's go to VPC1 and edit the route for this, add route. So subnet for VPC2 is 10.110/24. So it's 10.1.1.0/24. So before that, let's test if connectivity is there or not, just for testing purpose. So these are the two machines that are there. So if we try to ping these machines, so we are not able to ping, right? So these are the different machines that are created in different VPCs. So if we see that this is 10.1.0.0, this is VPC 1, and this machine is in VPC 1, and this machine is in VPC 2. So if we are trying to ping these machines, we are not able to ping. Okay. So let's update the routing tables first. So let's go to routing table, transit gateway, save changes. Okay, so for routing table for VPC1, we have updated it. Like to go to VPC2, we have to go through the transit gateway. So let's similarly update the routing table for VPC2 and edit routes. So for VPC1, it's 10.1.0.0.24, add route 10.1.0.0./24. It should again transit gateway. Save changes. So we have updated the route tables, and Now let's go to our transit gateway. We have already explained the settings and routes are updated. So now if we go to our machines, then connectivity should have been established. See, so from VPC to VPC1 and from VPC1 to VPC2. So we are able to ping the machines between two machines. So I hope you are able to understand the concept, how we are leveraging transit gateway to establish communication between two VPCs, and we are able to ping the machines over the private IP addresses. So these are the private IP addresses from VPC1 to VPC2. So this is 10.1.1.1.2.3.4 is the machine that is there in VPC2, and 10.1.0.1.1.2 is the machine in VPC1. So we have established the communication between these two VPCs using the transit gateway. So I hope that was helpful in understanding the concepts. So I hope it was helpful for understanding the another beautiful concept and enabling connectivity between different virtual data centers, and also we can, using this transit gateway, we can establish connectivity to on-premises network also using VPN and using direct connect also. So we can establish communication from virtual data center over the cloud and on-premises data center. So that was it for this for this video, and thank you for watching this video. And the important thing is that do not uh, forget to remove these resources, else you will be charged for these, because transit gateway is charged on per hour basis. So for the number of hours that you use this service, transit gateway, you are being charged for this. So just for precautions, you should delete these resources from the, once your demonstration is over or your testing is done. So remove these resources. So that's it for this video. Thank you for watching this video, and if do like this video so that more and more people can clear their concepts for related to AWS cloud network services. And you can subscribe to my channel. I'll keep on adding these exciting videos for exciting concepts on AWS cloud. Thank you. Bye bye. Hello, everyone. So I hope you are doing good and safe at your homes. So Techinforay is back with another video and with another impressive concept in AWS Cloud. And you can watch these videos in my, also I have created some other videos in which I have completed and shown practically these impressive concepts of AWS Cloud. Also, it's a part of AWS Cloud course that we have launched a few days back. And in case you have training requirements, you can contact us and then we can discuss about the trainings. And in training, we are covering the basic technologies also, and anyone can start from basic, and then slowly we move towards advanced cloud concepts so that concepts can be digested easily. And as a part of knowledge sharing, I am creating these videos, and you can watch these videos and subscribe to my channel and like my videos, and you can enhance your knowledge as well. So let's move forward. So as a part of network services and compute services, I am creating these videos and showing practical demonstration in these videos. And in my previous videos, I have covered AWS network layer components like creation of VPC, routing, switch, subnets, internet gateway, elastic IP concepts, NAT gateway concepts, and VPC peering connection in same and different regions. So there are certain configuration changes or differences while creating a connection in same and different region. So, and also as a part of transit gateway, in case our customer is having more than one VPC or more than one virtual data centers, so they can use AWS transit gateway. So in my previous video, I have covered in the same region And as a part of AWS compute layer components, I have created videos like for creation of Windows and Linux instances and load balancing, enabling load balancing to distribute traffic between more than 2 instances, and publishing the pages over internet. And also another beautiful concept called auto scaling group. So in this auto scaling group, you can learn automation into cloud and scale in and scale out. That is totally automatically. You can just based on a click of a mouse, you can increase your capacity, add more instances, and as per the scale in and scale out policies. So it's a really interesting topic, and you can watch that video and understand the concept of that. So in this video, what I'm going to cover is AWS Transit Gateway in different region. So in this, if a customer want to establish connectivity using AWS Transit Gateway, or has a requirement, like use cases can be they are having two networks in different regions, or more than two networks, and they want to establish communication. Because as I described previously with VPC peering connection, in case there are two or more VPCs or virtual data centers over the cloud, and establishing communication between them, then it's get a little bit complicated or a little bit complex to manage all these VPC peering connections, because it like works n+1. Like if you want to establish communication between 3 data centers and 3 virtual data centers over the cloud, then we have to establish uh, 3 VPC peering connections. So to manage all those connections, it gets complicated. But if a customer is having like one virtual data center or one VPC in one region and another in same or another region, and they want to connect to only one VPC or virtual data center, then VPC peering connection is sufficient. But in case a customer is having more than 2 VPCs, or more than 2 or 3 VPCs, then Transit Gateway is a good option to select this and establish communication between these VPCs, and in the same region or different region. So in this practical demonstration, I'm going to cover establishing Transit Gateway concept, and if in case VPCs are in different regions. So these are the use case, like customer A wants to connect to customer B in different region, and they want to provide some services like POC, or customer A has overtaken the business of customer B, and they approach to that I want to establish communication between these two virtual data centers. So in this case, we can use AWS Transit Gateway and establish the connectivity between two different cloud networks, cloud virtual data centers, or VPCs, and in different regions, and connectivity can be established in that. So as a part of diagram, I'm going to show this, that we have two different regions, and as a part of connectivity, we are going to, in the practical demonstration, I have created this scenario. Let me show you diagrammatically. So in region 1, I'm going to establish two VPCs, like VPC of customer A, VPC of customer B, and in another region, like this can be Asia, and this can be US. So these are two different regions, and in US we have another customer called customer C with virtual private cloud, or we can say virtual data centers, and they want to establish communication between them. So in this case, we are going to create transit gateway for this region and create transit gateway for this region. And to establish connectivity, we will send request from transit gateway of Asia to US, and also we will establish communication between these two VPCs as well. And once we have uh, established connectivity between these two transit gateways, then these both VPCs will be able to communicate with this VPC also, and this VPC can communicate with these two VPCs. So it's quite interesting concept, and establishing the connectivity over the two different regions, and this two connectivity will be quite secure, and it will be encrypted one. And I'll also create the instances in different regions so that we can check the connectivity by pinging the private IP addresses of these instances from both sides. And you will see all this practically, and this is a really interesting concept to establish connectivity between two different regions. And mostly customers have this requirement because sometimes they want to promote their business or establish business in another part of the world. So in case they want to establish communication between these two different regions, so then we can use transit gateway, because in case we have more than two VPCs, then transit gateway is a better option to move forward and establish the communication. So let's move forward and see practically how we are going to do this, and watch all those steps, and you can create your own transit gateway in your own account. And in case you want to learn like how to create all this basic components like VPC, creation of instance, subnet, and all these basic components in different region, you can watch my previous videos for networking and compute layer. So in this video, I'm just going to cover the configuration of transit gateway in different regions, and we will try to establish the connectivity. So I hope you will enjoy this concept, and you can follow my steps and create this really interesting demonstration. So let's go to AWS console and create this practically. Okay, so I'm onto AWS console. So I have, as I have described in the diagram. So also in my previous videos, I have shown that how to connect two different VPCs in the same region using transit gateway. So in this video, as I described on my diagrams, I'll show you that how I'm going to connect two different VPCs in different regions. So here I'm into Mumbai region, and I have two Mumbai region, and I have two VPC, VPC2 and VPC1. So using transit gateway, I'll enable communication between these two VPCs as well as between the VPC of another region. So that's into, let me go to another region. So this is, I'm into North Virginia. So this is North Virginia, and I have created one VPC into NV, VPC NV. That's the 10300/16 in North Virginia. So I'll enable communication between these three VPCs and using transit gateway concept. So that helps to clear your transit gateway connecting two different VPCs in different regions. So let's create the transit gateway connection. So here, let's go to VPC, and let's go to transit gateway. Transit gateway. Create transit gateway. NV to Mumbai PG001. Allow communication between NV and Mumbai. Okay. Let's keep everything default and create transit gateway. So it will take some time, and our transit gateway will be enabled after that. And in the time being, let's create the attachments. So create new attachment. So here, so transit gateway is not created as of now. So let it get created, and then we can create that. So similarly, let's go to Mumbai. So let's go to transit gateway and create a transit gateway. So Mumbai NV PG001. Allow communication between Mumbai and NV, right? So let's create transit gateway, close. So it's getting created. So let's get back to NV, refresh it. So now our transit gateway in North Virginia is created. Let's go to create the attachments for VPC and peering connection. So create. So here, let's create the attachment first with the VPC that is behind this transit gateway. So let's select VPC NV, and that's the subnet behind this. Create attachment, close, and create another attachment for peering connection. So using this one, peering connection, region, we are into NV. Let's select Mumbai transit gateway acceptor. We need to select the ID. So it's pending. Let's select the ID. Create attachment. Close. So we are initiating the request from Mumbai, from North Virginia to Mumbai. So let's go to Mumbai attachments. So let it get ready, then we can, so our Mumbai transit gateway is ready. Let's create the attachments. So we have a request from North Virginia. So let's accept this request for peering. Let's create attachment for VPC. Select VPC1, create attachment, close. Sorry for a bit confusion because I have tested few of the demos previously, so those I have deleted. So these in red are deleted. So this was the request, a pending request that is created from North Virginia. So let's accept this request, accept, and let's create another attachment with VPC2, VPC2, create attachment. So this will take some time. Let's wait for some time and let's go to North Virginia. So request has been initiated. So yes, VPC peering connection, VPC is available, but this connection between North Virginia and Mumbai, NV to Mumbai attachment. So in the meantime, let's wait for some time. It's pending. So here on Mumbai, this is the attachment for associated. It's also pending. Peering is being created. It takes some time, but it will be ready after some time. So just for naming convention, let me check the VPC ID. Your VPC ID for this one is B4BC. Transit gateway attachment B4BC. Yes, this is VPC1 attachment. VPC2 attachment. So we will use in the routing table. So just for naming convention, let's wait for peering connection getting ready. So this takes some time. Okay, so our peering VPC transit gateway peering is ready now. So this is Mumbai NV peering. So you can see our three on Mumbai, we have two different VPCs. So VPC1, VPC2, and peering between Mumbai and NV. So let's go to NV side. Okay, so here is also it's ready. So let's go to the transit gateway route table to update the routes. So associations are in place, the routes. So VPC route is in local is in place. Let's create the routes for networks, VPC networks on Mumbai side, 10.1.0.0/16, fuse attachment. So here, just keep in mind, there are two attachments. One is for the local VPC and another is peering between North Virginia and Mumbai. So we have to select this peering one. Create static route, close. Create another static route for second VPC 10.2.0.0/16. Peering, create static route, close. So this will be available after some time. Okay, let's go to Mumbai side also, and transit gateway routes, and these are locally propagated. Let's add route for North Virginia network as 16. Again, we have to select the peering one, create static. Also, let's update the routing tables. Let's go to routing tables. So let's update the routing table of VPC1, edit route, add route 10.3.0.0/16, transit gateway, VPC1 attachment, save, get back to routing table, update the routing table for VPC2 also, edit routes, add route 10.3.0.0/16, transit gateway, VPC2, save. And similarly, let's update the routing table for 10.1.1.0.0/16, transit gateway, VPC2 attachment, save. So here we have routes for all the networks. This is North Virginia network, and this is VPC1. So let's add the routing table of VPC1 towards VPC2 also. So here a route for VPC2 is missing, 10.2.16, transit gateway, VPC1, save attach. So now let's go to EC2 instances and connect them. So instances, so this is my North Virginia instance, duplicate session, EC2-user. Okay. And this is my VPC in Mumbai, duplicate session, EC2-user. Okay, let's open another session for VPC2, new session. So this is instance in VPC1, and let's open VPC2 instance, connect this one. SSH auth browse Mumbai private key, open EC2-user. Okay, so guys, take a look. So this is VPC2 machine. This is VPC1, VPC2, North Virginia, 3, 1. Okay, so let me keep them on all the tabs and let me mention it. So this is North Virginia. This is Mumbai VPC2, Mumbai VPC1. So we should be able to ping all these machines through transit gateways. So let's try to ping this one, 10.2.1.114. So I'm pinging from in Mumbai only. Ping dot 10.1.1.112. So I'm able to ping between Mumbai, between two VPCs. So VPC1 and VPC2. Okay, so this we are able to ping. So from here, we should be able to ping these both the machines, this one and this one. So let's try to ping 10.1.1.112. Sorry. So let's try to ping. Yes. So I am able to ping from North Virginia to Mumbai VPC1. And let's try to ping from Mumbai VPC1 to private IP of North Virginia. Yes, I am able to ping. So from North Virginia, let's try to ping private IP of second VPC 1.114. Yes, I am able to ping this also. So let's from here, let's ping private IP. I think I lost the connection duplicate session. EC2 user ping 10.3.1.187. Yes. So we have established the communication using transit gateway between the different regions, virtual data centers between different regions, NV to Mumbai, and in Mumbai, different VPCs also. So that helps to clarify the concept of a transit gateway between two different data centers, that too in different regions. So I hope you have enjoyed the concept, and please like the video and subscribe to my channel for more exciting AWS concepts. And let me know in case you have any queries and questions. I'll be happy to help you. Thank you. Thank you for watching the video. Hello, everyone. So I hope you are doing good and safe at your homes. So Techinforay is back with another video and with another impressive concept in AWS Cloud. And you can watch these videos in my, also I have created some other videos in which I have completed and shown practically these impressive concepts of AWS Cloud. Also, it's a part of AWS Cloud course that we have launched a few days back. And in case you have training requirements, you can contact us and then we can discuss about the trainings. And in training, we are covering the basic technologies also, and anyone can start from basic, and then slowly we move towards advanced cloud concepts so that concepts can be digested easily. And as a part of knowledge sharing, I am creating these videos, and you can watch these videos and subscribe to my channel and like my videos, and you can enhance your knowledge as well. So let's move forward. So as a part of network services and compute services, I am creating these videos and showing practical demonstration in these videos. And in my previous videos, I have covered AWS network layer components like creation of VPC, routing, switch, subnets, internet gateway, elastic IP concepts, NAT gateway concepts, and VPC peering connection in same and different regions. So there are certain configuration changes or differences while creating a connection in same and different region. So, and also as a part of transit gateway, in case our customer is having more than one VPC or more than one virtual data centers, so they can use AWS transit gateway. So in my previous video, I have covered in the same region, and as a part of AWS compute layer components, I have created videos like for creation of Windows and Linux instances and load balancing, enabling load balancing to distribute traffic between more than two instances, and publishing the pages over internet. And also another beautiful concept is called auto scaling group. So in this auto scaling group, you can learn automation into cloud and scale in and scale out. That is totally automatically. You can just based on a click of a mouse, you can increase your capacity, add more instances, and as per the scale in and scale out policies. So it's a really interesting topic, and you can watch that video and understand the concept of. Okay, so in this video, I'll cover creation of secure IPsec VPN connection with on-premise DC or data center. So here we are creating an environment, but we are going to use AWS Cloud in this case. Let me tell you that. And but it will be similar to like that, only that creating a VPN connection with the customer on-premise DC, and that too over the internet. We will going to use public IP addresses, and our all traffic will be over the internet, and it will be similar to like that only. So in this demonstration, I'll try to create that kind of environment, but it will be similar to that only. So the main objective is that clearing of concept of VPN connection, creating that VPN connection using AWS VPN components and VPN connection, and establishing it a secure connection in case a customer is having a requirement. Like use cases can be like customer is having a virtual data center or VPC network on the cloud, and they want to establish communication between the cloud networks and on-premise network. There can be, it can be like for data migration, or they want to establish server communication with AWS cloud servers, and servers that are lying on premises. So it can be a sort of creation of hybrid cloud infrastructure, where their customer have placed some servers on shared infra, and they have placed some servers on on-premise DC. So it's a sort of creation of hybrid model in the cloud. Or our customer is already on the cloud, and they want to establish communication with another customer that is not on the cloud but on his on traditional data center. So in that case also, we can use this creation of IPsec VPN tunnel to establish a secure and encrypted connectivity using AWS VPN gateway between customer cloud networks and customer on-premise data center. So in this, what I'm going to cover is I'll configure the VPN component VPN gateway and VPN connection. And on the customer's on-premises model, I will create one AWS instance and install OpenSWAN server on the instance, and it will be in the different region, and this will be in a different region. So the communication will be over the internet, and this will be a sort of on-premise data center of customer or network. So the address will be 10300/16, and VPC, that is on the AWS cloud, 10.100.16. So in case you want to learn like how to configure VPC and basic network components, creation of subnet, and launching of Windows machine or Linux instance, you can watch my previous videos. So in this video, I'm going to lay stress on creation of VPN connection between AWS cloud and customer on-premises. So in this, I'll launch one machine in VPC, and then I'll configure customer VPN component using the public IP address of this server. So on the on-premises CD DC, customer VPN server can be anything like firewall or router or any VPN device that has the capability to establish IPsec tunnel. So this VPN connection can be established with that particular device. So I'll create a customer VPN component using the public IP address of customer server and VPN gateway, and create a VPN gateway and attach it to the VPC. And then we'll create a VPN connection using both of these components and configure them, and then move towards the instance and install OpenSWAN VPN server on this, and configure it by downloading the configuration and configure this server. And then once configuration is complete, then we can see that this connection is up and running. And I'll show you all these steps practically. You can watch each and every step, and you can create your own this connection or demonstration in your account, in your AWS account. And then after that, I have also, then once the connection is established, everything is green, then what we will do is from this instance, I'll ping the private IP of this server just to showcase that we can ping the private IP. And this shows that the VPN connection is established and we are able to reach the private networks from AWS cloud to the customer private network. So I hope you will enjoy this, and you will get clarification about establishing different kind of connectivities with AWS cloud. And also you can watch my previous videos for other interesting concepts. So let's move forward to AWS cloud console, where I'll showcase everything practically step by step, and you can copy all those steps and create your own demonstration. And I'll paste the configuration details in the comments also. So in case you have any questions or queries, you can contact me and like my videos for another interesting AWS concepts. And you can subscribe to my channel for updates. So let's move forward to AWS Cloud Console and create an interesting demonstration practical for this IPsec VPN connection.
Okay, guys, so I'm into my AWS console. So here I'll go to instances. So as I described in my diagram, we will create a VPN between two different VPCs. So here I'm into North Virginia, and we will create VPN between Mumbai and North Virginia. So this is the instance that on which we will install OpenSWAN VPN and create site-to-site VPN connectivity. So let's access this instance, and I have allocated Elastic IP to this.
So this is the elastic IP that is allocated. So let's copy this and move to Mumbai to configure the VPN. So let's go to VPC. So in Mumbai, I have two VPCs, VPC1 and VPC2. So I'll create. I have created instance in VPC1 and VPC2. So first, I'll show you that how to create a VPN between Mumbai and North Virginia, and then I'll establish the connectivity between VPC in Mumbai and North Virginia. So let's go to VPC and create VPN. So customer gateway. So here we need to create customer gateway on another side. So here our customer is VPC in North Virginia. So customer NV gateway. So static, we will provide our elastic IP that we have allocated to our machine. So create customer gateway. Okay, moving forward, let's create virtual private gateway for Mumbai. We are creating virtual gateway Mumbai VPG. Create virtual private gateway. And we need to attach it to the VPC with which we need to communicate. So let's attach it to VPC1. Yes, attach. So it's attaching. Let's refresh it and it will get attached after some time. So let's create a site-to-site VPN connection. Create VPN connection, name Mumbai NV VPN connection. So here we will use virtual private gateway. I'll create another video where I'll show you transit gateway as well. So as of now, we are creating using virtual private gateway. So I'll select virtual private gateway that we created for Mumbai, and for customer gateway we have created it. This one, static. So the network behind that, if we go to North Virginia, so let's check the network. So I go to VPC. So here we will check the network that will be behind the our OpenSWAN VPN. So this is a sort of customer network. So we will select this VPC NV 10300/16. 10.3.0.0/16. So let's keep everything default as of now and create VPN connection. Close. So this will take some time. Our VPN virtual private gateway for Mumbai is ready. Customer gateway is ready, and site-to-site connection is pending. So let's move to North Virginia machine and install OpenSWAN VPN on it. So if we go to instances, let's access the instance, and we will access that instance through PuTTY and install OpenSWAN VPN on that. So this is our OpenSWAN VPN instance. Copy the IP and access it through PuTTY. Let me connect using the NV key. Open. Yes. EC2-user. So let's get into sudo super user and yum install OpenSWAN -y. And one more thing, let's download the VPN configuration from Mumbai gateway. Download the configuration. So here we will select OpenSWAN. Select OpenSWAN and download the configuration. So we will use this configuration while configuring the VPN on another side. Cancel, open it. So here is the configuration. So we will use the same configuration. We will make some changes in this. I have gone through some Unix Linux sites, so I need to make some changes in this configuration and it will work. As of now, I have tested this, it doesn't work, but let's make some changes. Either you can copy this whole configuration and create your own configuration, or let's make some changes. It will be easy because this is already having like details of the gateway and all this. So we have to make very less changes in this. So I'll copy the final configuration in this. So there are some changes that we need to make. So these are the two lines that we need to change. I tested this, it doesn't work as it is. So let's change those. I went to some Unix site to configure OpenSWAN. So they suggested like this. So this will work like this. And we need to remove this line as well. And rest we will copy and paste. Okay, let's open to our site. So our OpenSWAN is ready. So first is that we need to copy the configuration in this file. Let's use Vim editor and paste. So right click and you can paste the commands in this. Press O for next, and let's copy these lines. Control C, right click, and there you go. Let's remove hash. If it is hash, then this line is not enabled. So we have to remove the hash. Oops. Enter. Okay. So to save the file, press escape :WQ. Okay, our file is ready. Let's move to next step. So we need to remove hash from this file, and it should not include hash. So let's confirm that. Vim. Okay, so hash is not there, so it's already removed. So if you do not want to make any changes or do not want to save any, :Q. So this is also ready. So here we have also to make some changes, like what's the network behind OpenSWAN and network behind the Mumbai gateway. So network behind our OpenSWAN is 10.3.0.0/16, and network behind VPN gateway is our Mumbai VPC, that is 10.1.0.0/16. So let's copy this configuration in our file. Vim configuration, and let's copy this configuration. Right click, paste, escape :WQ. So it's saved, and let's create shared key secrets. Copy this, open in Vim editor. So here are both the gateways are defined, that is OpenSWAN and our AWS VPN gateway. So let's copy this whole line with shared key. Escape :WQ. So our VPN configuration is almost done. There are 2-3 commands to start the services. Service network restart. That's okay. Service IPsec start. That's nice. So let's check the status now. Okay, so now you can see our status is active and running. So let's go to Mumbai side and check the VPN status. So our VPN gateway is available now. Let's go to tunnel details. So we have created the configuration for tunnel 1. So this will come up after a few seconds. So let's refresh it. Okay, so now our tunnel is up now. So let's test the connectivity by pinging the machine. So let me go to the instances in Mumbai. So I'm already into Mumbai region. So let me access the instance in VPC1. Instance VPC1. Let's copy this IP address. Open new session. Control V. Select the private key. Browse Mumbai. Open. Yes. EC2-user. Okay, so this is the private key, and so this is the machine that we have configured VPN, and this is the machine in Mumbai. Let me mention. So this is instance in VPC 1 in Mumbai, and behind our VPN gateway. And this is our OpenSWAN VPN that we have configured on NV side, North Virginia. So now we should be able to communicate between these two sites. So this can act as our on-premise site because we are creating VPN, and this is the AWS Cloud Gateway. So let's try to ping the private IPs. So let me ping this one. Private IP of this is pinged 10.1.1.195. Not able to ping. Let's check the routing. Let's go to VPC in Mumbai. I think we missed one step, that is of routing, route tables. So that is, oops, PS VPC1, edit route, add route. So 10.3.0.0/16. So it should go through the virtual private gateway, Mumbai save. So now let's get back to our machines. So they should be able to ping now. Ten dot 3.1.145. Yes, from here we are able to ping the public private IP of the machine behind the IP address of OpenSWAN private IP. So from here, let me allow the security group in North Virginia. Yes, let's go to North Virginia. Yes, let's go to security group. Security groups. Let me check inbound and outbound connections. Inbound is allowed, outbound is allowed on North Virginia. Let's go to Mumbai. Mumbai security groups of public, all traffic outbound, inbound traffic ping is not allowed. So let's edit inbound rule, add rule, ICMP, version 4, anywhere, save. So let's get back to our machines. Yes, so now we are able to ping. So we have to keep in mind the access also on both the virtual firewalls behind all the gateways. So now we are able to ping from North Virginia, OpenSWAN, and Mumbai region. So we are able to ping now. So I hope it was quite easy to create a VPN, and I hope it helps you to clear the concepts of creating a VPN and creating a hybrid cloud model between AWS. So here we have clarified the use case that if a customer wants to connect on-premise network with AWS cloud using IPsec VPN tunnel, so you can demonstrate using this. So that helps to clear your concepts related to IPsec VPN tunnel. So here we have connected one VPC behind Mumbai towards North Virginia, and so in case we have more than one VPCs, then we have to use transit gateway. So I'll cover that concept in another video. Thank you for watching the video, and please like the video and subscribe to my channel so that you can be aware about newer videos and concepts related to AWS Cloud. Thank you for watching. That's all for today. See you in the next video. Hello, everyone. I hope you are doing good and safe at your homes. So Techinforay is back again with another technical video to impart knowledge to students and cloud learners. So this time we are trying to create more awareness on network technologies that are there in the AWS cloud. Also, we have launched AWS cloud course, and we are covering all these concepts in the course as well. So if you have any requirement for training, you can contact us, and we can discuss about the training. But also as a part of knowledge sharing, you can watch these videos to get more knowledge and clear your concepts as well. So moving forward, so it as a part of cloud services and demonstration network and compute practical demo, I have created this video to cover network service. So in my previous videos, I have covered network and compute layer component practicals. And like in network layer, I have covered routing, subnets, internet gateway, elastic IP, creation of virtual data center or VPC, and creation of NAT gateway, VPC peering connection, like customer want to establish communication between two different VPCs, then we need to use VPC peering connection. And in case customer is having more than one or two or three VPCs, then it gets a bit more complex. Then we need to use transit gateway, and I have created videos for creation of connection between two different VPCs in same and different region using transit gateway. Also, another connectivity can be like establishing of IPsec VPN connection to customer on-premise data center from AWS cloud. So I have showcased and create environment and creation of VPN connection using VPN gateway. And as a part of AWS compute layer components, I have created videos for creation of Windows and Linux instances, and used load balancing and to distribute the traffic between two or more Linux or Windows instances, and another beautiful concept called auto scaling group to learn automation in cloud and also see scalability that automatically scaling instances and adding of instances and deletion of instances. So to understand the concept, you can watch these videos. So in this video, what I'm going to cover is that creation of IPsec VPN connection and that using a transit gateway. In my previous video, what I did, I used a VPN gateway, but the difference comes on like if a customer is having more than one VPC, like customer is having VPC in more than one VPC in AWS cloud, like VPC A or VPC B, then in that case, like if we are using VPN gateway, then we have to create multiple VPN connections. But to resolve that problem and make the thing simplified and remove the complexity of management of different connections, what we can do is we can use AWS Transit Gateway between customer VPCs on AWS Cloud and on-premise DC. So as I explained in my previous video also, and in this previous video, I'm not going to connect or create exact customer on-premise data center, but what I'm trying to do is I am creating these VPN components in region 1 in AWS Cloud, and I'll create these components in another region like this I'm creating in Asia, and this I'll create in US. What it'll be same like we are connecting to customer on-premise and creating similar sort of environment. The main objective of this uh, creation of video is there to clarify the concept of creation of IPsec VPN connection uh, uh, between AWS Cloud and customer data center. But we are using this AWS Cloud only to showcase this practical. But understand and create these components, and this will help you to clear your concept using Transit Gateway. So use cases can be like customer is having multiple data centers, virtual data centers, or VPC networks on AWS Cloud, and you want to establish communication between AWS Cloud networks and on-premise networks. For it can be like for data migration, or customer is having some of the servers on cloud on AWS Cloud and some of the servers on premise data center, and they want to establish communication between these two servers for data migration or data transfer. So then we can use this IPsec VPN tunnel to establish the communication. So in this case, what I have done is I have created two VPCs, VPC A with the network 10.100/16 and VPC B with 10.200/16. And in case you want to understand how to create these VPC subnets, routing concepts, and all these components, then you can watch my previous video and you can understand how we can create these all these components. And also I've launched one machine in VPC 1 and another machine in VPC 2. And again, if you want to understand like how to launch the instance, you can watch my previous video. So in this, my main stress will be on creation of VPN components and installing a VPN server on another region. It can be like a customer on-premise DC. And in this also, I'll install a VPN server at the customer on-premise DC. So the process will be like I'll create a customer VPN component using the public IP address of the VPN device on customer side. So VPN device, if we talk about, is it can be any device that supports IPsec capability. It can be any firewall, router, VPN device, but the main thing is it should support IPsec functionality, and then we can establish this VPN tunnel. I'll create a customer VPN component, and I'll create transit gateway, and or we can establish communication between these two VPCs using this transit gateway. Later, I'll create one VPN connection using these two components, customer VPN gateway and transit gateway. So once this is created, then we will move towards another region or customer on-premise DC and install OpenSWAN server. So this is free software that we can install on Linux instance, and we will install OpenSWAN VPN software on this instance and configure it as per the configuration files that we'll download from the AWS cloud. So that makes easy for the configuration, and we will copy all that configuration with some changes, and I'll paste all those configurations in the comments so that you can create your own environment. So once this VPN server is ready, up and running, and then we can see that tunnel status on AWS cloud will come up. This shows that we have established connectivity. Then later what we will do is that this machine is also having one private IP. And then we will do, what we will do is, then we will, from this machine, machine in VPC A, we will try to ping the private IP of the same server. And then also we will ping from this machine to this machine. So this shows that we are successfully established the connectivity over the internet using secure IPsec VPN tunnel, and all this traffic will be encrypted, and we are able to reach the private networks and like private networks like from the machine instance over here and the private IP of this server, and we will be able to establish the communication that securely, and also we will be able to achieve our objective that customer is having more than one VPCs, and using transit gateway we are able to create a VPN connection and able to establish the connectivity. So let's move forward and create all this environment practically. I'll show you all these things practically, and we will make the configurations. So you can use all that configuration on your own account and create this. So let's move forward to AWS console. Okay, guys. So I'm into my AWS console, and as I have described in my diagrams, we are going to set up a VPN between Mumbai and North Virginia IPsec VPN tunnel. So this is my Mumbai region, and I have two VPCs. So in this also we will cover like we'll create a site-to-site IPsec tunnel using transit gateway, because there was the problem is that if we are using a VPN gateway only, then we are able to communicate with one VPC only. In case we have multiple VPCs behind the AWS gateway, so then we need to use transit gateway. So here in this case, these are the VPC1 and VPC2 in my Mumbai region. And if we go to North Virginia region, so here I have VPC, but here I have created one server Linux machine. I have launched it, and we are going to create this OpenSWAN VPN. We will make this server as a OpenSWAN VPN server and create site-to-site VPN with this server, and we'll create site-to-site VPN between with this server and Mumbai AWS gateway server. So I have allocated Elastic IP to this machine, and let's go to Mumbai region and create, first let's create transit gateway, then we will create VPN connection. So let's go to transit gateways, create transit gateways, Mumbai TG 001, Mumbai TG. Let's keep everything default and create transit gateway, close. So this will take some time. Let's create attachments, create attachment, but let's wait for some time to get this transit gateway created. It takes some time to complete the creation. So let's refresh it, and okay, our transit gateway is ready. Let's quickly create the attachments. Create attachment, VPN gateway, VPC. So let's attach these two, VPC1 and VPC2. So we are going to attach one subnet only, create attachment, close, create another attachment for VPC2, VPC type, select the VPC, VPC2. Okay, create attachment. Okay, our attachments are ready, and transit gateway route is available, associations, routes. So this will automatically will be here, and we will add the route for VPN gateway once it is created. So let's move forward and let's create the customer gateway. So we will create customer gateway as per the NV customer gateway. So we will use the Elastic IP that is allocated to the server. Create customer gateway. Close. So here we are not going to create a virtual gateway because we are going to use transit gateway. So let's create a site-to-site VPN connection, name Mumbai and the VPN connection. So in my previous video, I have selected virtual private gateway. So let's select transit gateway over here that we created before, existing customer gateway, NV customer, routing static. Let's keep everything as default, create VPN connection. So it will take some time to get created. So let's see when this will be available. Okay, so our VPN connection is available now. Let's see the tunnel details. So both the tunnels are down. So also let's complete the configuration on transit gateway as well. Let's go to transit gateway route. So the routes are automatically propagated. We need to create one static route for the network that is behind the OpenSWAN server, port 0.0/16. Choose attachment. So we are going to choose our VPN. Create static route. Close. Also, do not it will automatically appear after some time, and we can see that yes, it's a black hole because our VPN is not enabled as of now. So when it is connected on both sides, then it will be enabled. Also, do not forget to update the route tables for the VPCs that we have created. Like for if we see the public route table for VPC1, I have added both the networks. This is behind the another VPC, VPC2, and this is the network behind the uh, customer gateway. So these both are going towards the transit gateway. So let me check the connectivity between these VPCs. So this is my VPC1 machine and this is VPC2. Let's try to ping these machines. Ping from VPC1 to VPC2, 10.2.1.73. Yes, we are able to reach. So let's try to ping from VPC2, 10.1.1.226. Okay, so using transit gateway, the connectivity between VPC1 and VPC2 is established. So let's go to the VPN connection and then establish the connectivity. Let's go to VPC and download the configuration file for VPN connection and configure the VPN on OpenSWAN. So here I'm into VPN connection, site-to-site VPN connection. Click on download configuration, select OpenSWAN and download configuration. Linux OpenSWAN, save yes. Let's cancel this, open this file. So here is the complete configuration of the file that we need to paste it. So we have to make some minor changes in this file and then we can copy paste it. So in this, we have to change these two lines because it doesn't work, and I have followed some Linux site on internet and they suggested the configuration of OpenSWAN. So let's make some changes in these two lines. I'll copy this configuration in the comments so you can use all this configuration as it is. So one is this and another is we need to modify the networks. So left networks is the network behind the OpenSWAN server. So our network behind OpenSWAN server is 10.3.0.0. That is NVNet VPC network 16. And we have multiple networks behind AWS gateway. So let's use 0.0. Done. Okay. And in this, remove this line. Okay. So now we can copy all this configuration in our VPN OpenSWAN server. So this is our OpenSWAN server. I have installed the OpenSWAN software in this. So command to install OpenSWAN software is yum install OpenSWAN -y. So I have already installed it. So it's saying that already installed and latest version. So you can just run this command and install the OpenSWAN. So just let's copy this file first configuration into this file. So vim, right click and paste it. Come down, press O for next line and copy these lines. Control C, right click to paste. Let's remove this hash sign in front of this line so that it can be enabled. Okay, so it's enabled now. So to save the contents, press escape :WQ. So here you can see escape WQ. Press enter. So our contents are saved in the file. And let's move to next configuration is OpenSWAN conf. And in this we need to remove hash sign before this file. So vim. Okay, in this hash is already removed. So escape :Q. We are not going to change anything or save anything. Move to next file. So let's update this file as well. Control C, vim, right click, and copy all this configuration and paste it in the file. Copy, right click, escape :WQ. All right, so this is the last one. To copy the secrets, vim, right click, and copy this. This is the our OpenSWAN server, and this is the customer AWS gateway, and this is the pre-shared secret key that is generated. So let's paste this as well. Escape :WQ. Okay, so our server is ready. Let's start. First, let's start the network command to start the network service. Restart it. Okay, let's start IPsec service. Bash start. Sorry, service IPsec start. Great. So let's check the status. Service IPsec status. Okay, so our VPN on OpenSWAN server is up. Let's go to Mumbai region and let's see the tunnel status now. So let's go to tunnel status and refresh it. So we have created connection with tunnel 1 using this IP address. So it should come up now. Okay, so you can see that we have established VPN tunnel with uh, uh, our AWS VPN server, and we have established tunnel with site-to-site IPsec VPN server with tunnel 1 using this IP address, and you can see the status up. So let's try to ping private IP addresses from Mumbai regions. So this is my Mumbai region, and this is VPC1. And let me mention the diagrammatically. Mumbai VPC1, Mumbai VPC2. So we checked before these are able to communicate, and this is OpenSWAN server in NV. So we should be able to ping from here and from here as well. So let's try to ping the private IP. Let me restart this session, duplicate session, PC2-user. So this is VPC1, duplicate session, PC2-user, right? Okay. So this is VPC1, VPC2. So from VPC1, let's try to ping VPC2 10.2.1.73. Great. Let's ping the private IP of OpenSWAN server. Let me go to North Virginia and let me find the private IP. So this is the private IP of OpenSWAN 10.3.1.47. VPC1, VPC2, OpenSWAN server. Okay, so from here I should be able to ping 10.3.1.47. Sorry, ping 10.3.1.47. Great. And from here, let me try to ping VPC 1 10.1.1.226. I'm able to reach VPC 1. Let's try to ping OpenSWAN server behind the OpenSWAN IP address behind the OpenSWAN server 10.3.1.47. Great. So we are able to achieve the connectivity between on IPsec and in between the VPC. So we have multiple VPCs, VPC1 and VPC2, and we are able to achieve our connectivity over the IPsec VPN tunnel using the transit gateway and VPN connection. So we have connected our server customer, and using transit gateway, we are able to communicate between the multiple VPCs and over the IPsec tunnel to the customer. So it's a use case like a customer is having multiple virtual data centers or virtual VPCs over the cloud, and they want to communicate to the on-premise network. So I hope you have enjoyed the concept, and if you like the concept video, please like it and subscribe my channel. I'll keep on uploading newer concepts and videos for new concepts of AWS Cloud. Thank you for watching the video. Please do not forget to remove the components that we created, like a transit gateway and other elastic IPs, so that you will be charged for this if you forget to remove them. Thank you for watching the video. Let me know in case you have any comments or questions. I'll be happy to answer those. Thank you. Bye-bye. Hello, everyone. I hope you are doing good and safe at your homes. So Techinforay is there back with again another practical video. So in this video, we will cover very important aspect of technology called auto scaling group, and it's quite important in terms of industry use cases. So we will cover that in this video. So just a background, what we did before in my previous videos. So Techinforay has launched a cloud AWS cloud course, and all these technical videos and practical videos are part of the course. So I'm just uploading the content to share the knowledge. So in this, what we covered before, I'll just go through that very quickly. So in this, we have AWS has launched a AWS Cloud course, and these are the details and different modules and different labels and all the customer use cases that will be covered in the course. So this is just an overview what is being covered in AWS Cloud course that is launched by Techinforay. So moving forward, I have created some videos before covering different layers of network, compute, and storage, and database. So as a part of this video, I'll just go through these, what I did before in the previous videos. In case you missed that, you can watch those videos. So in this previous video, I covered a use case where a new customer comes on board and what different layers are being created for it. So in this, in the use case one, I covered network layer in which I created a VPC internet gateway attaching to VPC, subnets, routing tables, and firewalls. So here is the high-level diagram of the connection diagram of the network practical that is covered, routing tables, and virtual firewalls. So this is the network layer and different components what are being added when a new customer comes on board. You can add more subnets as well, but as per the requirement, you can add that as well. So moving to next use case two, in this we have covered allocation of elastic IP address, how we can allocate elastic IP address to different instances, and then creation of Windows server and adding web server role and publishing it over the internet. Similarly, creating a Linux instance, install web server, and publish the web page over the internet. So that was covered in use case two. So creation and allocation of elastic IP address, Windows instance, and then publishing the web page over internet, and then Linux instance, creating a Linux instance, connecting it, and then install web server and publishing the web page over the internet. So here is the high-level diagram of what we did in the practical. So we created subnets and installed machines in that and allocated elastic IP. So this is the compute layer that added as a part of practical demonstration. So in the next diagram, we will cover NAT gateway. NAT gateway is covered in the practical. So in this, we will demonstrate how a NAT gateway can be used for secure internet access, one-way internet access for private subnet instances, like they want to download important updates of security patches. So that can be enabled through NAT gateway. So here is the high-level diagram of NAT gateway, how it is placed, and from where it is connected to, from private subnet. So we have installed Windows instance and private subnet and connected it, accessing the internet through NAT gateway. So this is one way only. We cannot access back from internet. We cannot access this instance. So that's one way only. That internet is accessed from Windows instance only, not from network. So this is again another where network layer and compute layer is added into the scenario. So moving forward, then we came to know that if we are having different web servers, how we can share the load and using load balancer. So in the next previous videos, I have also covered how a load balancer can be installed and how a web server can be published over the internet using load balancer, and also we checked by stopping one instance how traffic can be diverted to another instance. So this is the high-level diagram where network load balancer is placed, and we have two instances in the public subnet. So now in this video, we will cover AWS Auto Scaling Group Practical. This is very important, and it has quite important use cases in the industry. So auto scaling group contains a collection of Amazon EC2 instances that are treated as a logical grouping and for purpose of automating scaling and management. So how it is done? It's done using health check and replacement and using scaling policies, and that is used in the auto scaling group. So the core functionality of ASE is maintaining the number of instances in that particular group. Like if we desire, like we want 10 machines, so auto scaling group will maintain that those number of machines, and automating scaling as per the requirement of the traffic or usage. There is automatic scale up and scale down. So the size of auto scaling group depends on the number of instances that you set as per your desired capacity while configuring ASG, and that can be just adjusted to meet the diagram demand, and that is also done either manually and by using automatic scaling policies. So why is the need of this auto scaling group? So like there are different challenges that lead the arise need for auto scaling group. Like instances may get corrupted during the operations, or instances are not able to accept the traffic from load balancer. CPU usage goes very high and we need to add more machines. And or during weekends or during the night, CPU usage goes very down, and so the machines are underutilized during that time. Or traffic increases instantly and we are not able to meet the demands, or traffic may get decreased during nights and weekends, and then resource wastage is there. And the another challenge is that all these tasks were done manually, like addition and deletion of machines as per the requirement. So with the usage of uh, auto scaling group, we got solution for all these problems. Like if instance some gets corrupted, so this auto scaling group automatically checks the health of the machines, and that machine is terminated, and automatically new machine is added into this auto scaling group. Or instance is not able to accept the traffic, then automatically another healthy machine is added. Or like then we have a lot of traffic on the auto scaling group, and the average CPU of the machines goes high very instantly. So to meet the demand, we have set auto scaling group to meet the demand. It automatically adds the machines to handle the high traffic. And maybe after some time, CPU usage goes very low, and then we need to shut down some machines. So because when the usage goes low, then some machines are underutilized. So automatically machines gets removed, and the average CPU utilization of ASG come down. Or like the problems are there, like traffic increases instantly and then traffic decreases. So automatically the auto scaling group adjusts the number of machines. In case there is no wastage of resources, because it automatically removes the machines which are not being used, or the we as per like if we set average CPU utilization comes down below 40, then remove the machines one by one. Yeah. So need to perform manual tasks for addition, deletion of machines. Then in this we have automation, like it automatically add and remove the machines. So you can see we got a solution for different problems. These are not a complete list of solution problems. There can be more problems in this, but in this video I'm covering these problems and mentioned the solution for these problems. So what goal we achieved in this is, like we are optimizing the cost, like the machines which are not being used, that are getting deleted automatically. So we are not being charged for the resources which are being underutilized. So meeting the capacity needs. So as per the requirements of capacity, the traffic goes high or low, we are meeting those demands. And there is no downtime in this. It's getting all automatic, and there's no resources not getting down or unavailable. So there is no downtime in this. And the very, very important concept, like automation in its infrastructure. So all these things are getting automatically added, deleted, and everything is done automatically. So I hope you understand what exactly we want to achieve and what were the problems and how solutions are being implemented into it. So this is the high level diagram. We will add auto scaling group in this. This is the auto scaling group, and we will automatically, it automatically adds the instances as per the requirement, as per like CPI utilization goes high or low. And we can also keep desired capacity, minimum capacity, and maximum capacity in the auto scaling group. But also in case we want everything to be automated, like if the utilization goes very high, then as per our scale in policy, scale in and scale out policy, it goes, the number of machines gets added and gets removed as well. So that can be achieved by using scale and scale in policies. So, and in front of this auto scaling group, we will configure a network load balancer, because we are going to share the network traffic among these different machines. So as per our requirement, if the machines are getting removed, automatically the resources from this network load balancer will be removed, and the traffic will not be sent to those machines or to those resources. And automatically, if machines are getting added, then automatically this will be added into the network load balancer, and load will be shared among those machines. So this is a typical use case in case we have where we have a web layer, and behind there can be application layer or database layer. But in this practical, we are demonstrating how we are going to achieve automation in a web layer. I hope you understand the concept. So let's move forward, and then we can cover all these things. I'll show you practically. Hello, everyone. So welcome back to another video of auto scaling group. So in the previous video, I discussed theoretically what we are going to achieve, what are the different problems that are being faced, and how we are going to provide solution using auto scaling group, and what goals are achieved. So all this was discussed in the previous video. So in this video, we will log into our AWS console and perform all these steps practically. So before moving in this AWS demo, I'll introduce to these services like AWS EC2 instance, Elastic IP allocation, AMI creation, launch configuration, and auto scaling group, SNS topic, network load balancer, and also we will configure a CloudWatch alarm to kick in the policies. So these are the steps like for creating ESG. So let's log into our AWS console, and before that, let's create a one Linux instance and install web server on that. Then we will create launch configuration for that. So let's log into our AWS console. Let's go to EC2 services. So we are into Mumbai, and in case you want complete details how we are creating web server, you can watch my previous video. So let me quickly create an instance. Let's launch Linux instance, select. We are using T2 micro, configuration details. We will place it in our demo AWS VPC that we created before, placing it in public subnet. And the rest we will disable as of now, and we will allocate Elastic IP for this. Add storage, keep it default. Add tags, yes, very important. Department, network. Security group, we will use our existing security group that we created before, public security group, and all these ports are already allowed in this. 80 port for accessing the web server from internet, 22 port for accessing the machines placed in this security group, and 3389 for accessing RDP. Review and launch. Launch, use our existing key pair. Launch instance. View instance. So for the time being, I'll stop the video, pause the video. So until this instance gets ready, I'll resume it. Okay, so in the meantime, our machine is getting ready. I'll show you how we can allocate Elastic IP. I also have shared the practical demonstration in the previous video. So let's quickly allocate IP address, Elastic IP address, so that we can allocate that Elastic IP to our machine, and we can access it from our internet. So let's allocate Elastic IP. allocate. Okay, we got our demo elastic IP. Save. And let's associate this with our machine. So we have a machine is running that we created, web server, associate. So let's go to instance. Let's see if machine is ready. So it's still getting initialized. Okay, so our machine is ready. So we will provide name Linux web server. Save. Okay, guys, our machine is ready now. We have allocated elastic IP address, that is demo elastic IP, and I have connected it to the machine. Let's access through PuTTY. So if you want to see how I connected this Linux machine through PuTTY, there is another video. So you can watch that, how to download the key and get the private key out of it, and how we are connecting to it. So I am into Linux instance. Let's get into sudo super user and quickly install the, okay, I am already into sudo. Yeah. So here are some commands. So let's first update our machine. So this will install all necessary updates. Yes. So take some time to download the important updates and updating the machine. So just for information, it's installing the AWS CLI also that can be used. Yeah, that's done. So everything is installed now. So let's install our web server. You can use these commands to install that, and let's quickly do that. Let's start the service. So our server is ready. So let's create our web page. Move this file and create our own index file. So this is a test page on Linux instance as a part of AWS ASG practical demonstration. So if we do this, create the page, restart the service. Okay, so now our machine, our web server is ready. Let's go to instance, copy this, and let's test it. Okay, I have copied our elastic IP that is allocated to the machine. So let's test the web page. So that's great. So this is a test page on Linux instance, that the page that we created on our web server. So our web server is ready. So let's create AMI for this as a part of our demonstration. So we have created instance, and launch configuration we will create for it. So let's go to the machine, create AMI for this, AMI actions, select this image and security, create image. Okay, demo ASG. So let's keep everything default, tag, department, network. Okay, create image. So if we go to AMIs, so it is pending. It will get created quickly. Okay, so our AMI is ready. So let's move to the next step. Let's create a launch configuration for auto scaling group. Go to launch configuration and create launch configuration. Name LC launch configuration demo ASG. Okay. AMI that we created before, demo ASG, let's select that. Instance type, we are going to choose free one that is available T2 micro. T2 micro. That's sufficient for the demonstration. Rest keep default things. Monitoring not enabled, we do not require as of now. Select existing security group or public security group. Okay, and keep here our existing one. KP Mumbai, I acknowledge, create configuration. Okay, so we have created the launch configuration now. So let's move forward and create auto scaling group. So hello everyone. So welcome back to another video of auto scaling group in continuation to previous videos. So in previous video, we have created a web server, Linux instance using the Linux instance, and we created AMI, and then we created a launch configuration for auto scaling group. So let's move forward and create auto scaling group out of it. Log into our, so this is our instance that is running. Let's go to AWS console. So our launch configuration is ready. So moving to auto scaling group. Create auto scaling group. Demo ASGs. So switch to launch configuration. Let's select launch configuration demo ASG that we created before. Next. So VPC, let's select our demo AWS public subnet. Next. So as of now, we are not attaching any load balancer because let's move step by step. I'll add the load balancer at the later stage. So before that, let's go through the configuration of it. So this we will attach load balancer at the later stage. So health check, it will take 300 seconds to check the health of the machines. Move to next. So this is quite important thing. So the desired capacity, what we require desired capacity. So let's keep it as 4. Minimum capacity in the group, let's keep it 2, and maximum capacity that it can go is 6. So what does this mean is desired capacity, minimum capacity, and maximum capacity. So this means that in auto scaling group, so let me go to the diagram to explain you better. So if we come to the group, so desired capacity is in the number of machines. We know like how much capacity we want to keep in the our auto scaling group. Like we know that at certain amount of time we require these number of instances in the auto scaling group, and it can go minimum up to 2 and maximum up to 6. And this minimum and maximum will come into picture when we are using scale in and scale out policies. So let's get back to our auto scaling. So desired capacity 4, minimum 2, maximum 6. So if we are keeping desired capacity as 4, so in case out of the 4 machines, any machine gets corrupted, automatically auto scaling group will add the another machine. So I'll show you that practically. So create next, add notification. Yes, we want to add a notification. So let's create SNS topic to get emails when anything like launch of machine or anything gets triggered. We want that we should get notification for that. So let's create a topic, send notification to, let me give my own email ID, techinforay@gmail.com. Foray@gmail.com. Next, add tag, network, department, network. Next. So this is the overview. Desired capacity scaling policy also we will I'll show you at the later stage how we are going to add scale and scale out policies. So here this is a notification about SNS topic. So auto scaling group that is created today, it will be sent to techinforay@gmail.com. So create auto. So our auto scaling group is it's getting created, and if we go to demo ESC group, we go to activities. So it has as per our desired capacity, so it has created the machines and launching EC2 machines as per our web server. So if we go to instances, so here you can see that these are the 4 machines that are getting initialized. So this Linux web server that we created for our creating the AMI and launch configuration. So these different 4 machines that are created as a part of auto scaling group. So you can see all this is being done automatically, creation of machines and all these things. So also let me create SNS topic so that we can receive notifications about this. So let's go to SNS. I'll show you how we can do that. Simple notification service. So I'm here into Amazon SNS service. So let's create first topic. So we are going to use standard for SMS and email notifications. So FIFO used for integration with services. So my demo ASG. So let's create topic, then go to subscription, create subscription, my demo ASG, select protocol email, techinforay@gmail.com, create subscription. Yes. So my subscription is created. Now it's pending configuration, pending confirmation. So we have to go to this email ID and confirm it. So let me go to my email. So we have this notification. So into my email ID, so confirm it. So it's confirmed. So you can unsubscribe it also at the later stage. So let's go back to our. So if we refresh this, it should show that it has been confirmed. Okay, so we got the status as confirmed. So let's go back to our auto scaling group. Go to EC2 auto scaling group. Demo ASG and Load balancing, health check, advanced configurations. So we are here into our auto scaling group. So these are the details. So if we go to activity, so we can create notification. So I hope you remember we have created our Techinforay, and let's create it. So for all these like launch, terminate, fail to launch, fail to terminate, we will get the notification in that. So our auto scaling group is ready. And here are the details: desired capacity 4, minimum capacity 2, maximum is 6. So this is ready. So if we see in the activity, all the machines are ready. So now if we want to test our desired capacity, so let's go to instances. So if we terminate one machine that is there in the auto scaling group, then it will. So here I'm trying to showcase is like if any machine gets corrupted or not accepting the traffic, or there can be any problem with the machine and it's not accepting that traffic. So here just what I'm trying to do is I'm terminating the machine as a part of like it gets corrupted or how auto scaling group behaves in that case. So let's terminate this machine. Terminate. So if we go to auto scaling group, demo ASG activity. So you will see the details over here once it is getting terminated. Refresh it. So let's see in our email if we get the notifications. So let's go back. Okay. So here is the notification that we are getting. So an instance was taken out of service in response to EC2 health check, indicating it has been terminated or stopped. So it's a part of that that we got notification that one of our machines is being terminated. So similarly, you will get a similar kind of notification in case some machine gets corrupted or not responding. So you will get that type of notification. So let's get back to our auto scaling. So here you can also see the activity. So you can see out of 4, 1 machine got terminated, and now ASG is into service and it is creating another machine. So in response to difference between desired and actual capacity, so increasing the capacity to 3 to 4. So all this is getting automatic. If you go to instances, one new instance will be created. So this was the instance that we terminated, and automatically another instance is getting created. So this you can see this is all automatic and how we can achieve automation into our infrastructure. So slowly this machine will be into service and our desired capacity will be achieved in this. So if we go to our auto scaling group, activity, yeah, successful. So it has automatically achieved the desired state, successful. And our machine is getting initialized. So as a part of, let's go to details and let's monitor it. So we can go to CloudWatch and watch these metrics. So here, let's create new dashboard. dashboard, create dashboard, my demo ASG dashboard, create dashboard. So we can select as a line, stacked area, number, bar, pie, whatever we want to add. So let's select this one, metrics, configure. So what we can do is let's go to our EC2 auto scaling group. So here it will show our demo ASG. So if we select our CPU utilization, create widget. So this is showing the CPU utilization. Also, we can add a number of machines as well. Line next, metrics, configure, EC2, auto scaling group. So let's go to load balancer. We can add number of active instances. Network ELB, target group. Yes, healthy and unhealthy counts. So this will be shown once we add the load balancer in this. So so now we can see CPU utilization for all the average CPU utilization for our machines. So let's get back and see our auto scaling group. So this is CloudWatch. Let's move it to new window. Instances, auto scaling, CloudWatch. Okay, so our auto scaling group is working fine. We have desired capacity, minimum, max. Next, we can add auto load balancer in this. Go to demo ASG, details, load balancing. Let's edit this. Network load balancer, select target group. We will do it later. Add load balancer. So HTTP demo ASG1 will be the load balancer, and we want to keep it internet facing. We will access our web server over the internet. Okay, create target group, our demo ASG1, add tag, department, network. Good. So let's update it. Subnet. Yeah. Select our public subnet. Update. So automatically this will create a load balancer. Let's go to our load balancer group. So if we go to load balancer, then we can see this will automatically create a load balancer. So load balancer provisioning has been started. It will take some time and our load balancer will be in place. So see automation, it's getting created automatically. Target group, our target group is in place. So all the healthy machines are being added to the target group of the load balancer. So after checking the health of the machines, it will show healthy over here. So later, once everything is ready, then we will access these machines over the DNS of the load balancer. So it's getting provisioned. Okay, so if we see in our target group, all the 4 machines are added and the health status is healthy. and load balancer is active. So load balancing has been added to the auto scaling group. So let's access the machine using the load balancer domain name, DNS name. Yeah. So here I have copied the demo ASG Amazon AWS.com. So if we refresh this, yes. So our web server, this is the test page, a Linux machine instance as a part of AWS ASG. But now we are not accessing using our Elastic IP, but we are accessing it using our load balancer DNS name. So load balancer is in place and running successfully. So let's go to our load balancer. It's active, target group is active. So now if we try removing any machines, it will automatically get into the target group automatically. So let's try to terminate it. So if we go to our auto scaling group, activity, yeah. So previously it has shown that load balancer has been enabled successfully. Refresh. So you might have got successful notification as well. Let's check the notification. So demo ASG. So this was the capacity increase. So we have removed another machine. We will get another notification. So we are getting that in the auto scaling group. So this was the test. So once we have terminated our machine, so you can see that ESC has directed load balancer to drain the machine, and automatically the capacity will be raised from 3 to 4. And if we go to our target group, so here you can see all the machines are healthy again. And let's go to monitoring, and let's watch monitoring for healthy and unhealthy host. Add to dashboard. So let's select our my demo ESG, add to dashboard. So here you can see all those details: unhealthy host, healthy host. So if you see this one, we can see that when we stopped terminated one machine, it was 4, came down to 3, again ASG added it to 4. So we can monitor this as well. So these are the different requests counts. So as of now, traffic is very low, so we cannot see much. So add widget. Next, CPU utilization. Let's add that. PC2 auto scaling group. Create widget. Okay. So it's very low as of now. We will test this as well. So let's remove this which are not required because there is not much traffic. Delete, 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 delete. Okay, let's remove these also. Okay, so we have only the important ones as of now: unhealthy, healthy, and CPU utilization. So we will monitor these. Okay. Okay. Let's go back to EC2. This is demo ASC target groups. So we have seen that auto scaling and load balancer are in place. So let's get back to our slide. So we have created auto scaling group, enabled load balancer, and launch configuration is done, web server is done. We have configured all these and created auto scaling group, and we have tested the desired capacity. We terminated one instance and we have kept desired capacity as 4. So when we one terminated it, it came down to 3, but automatically it again goes to 4. So that was the automation and auto scaling group. So let's move to next step, creation of auto scaling policies. So let's go back to our console. So if we go to our auto scaling group, demo ESG, and but before that, let's go to CloudWatch and create our alarm. In alarms, okay. So we need to create this alarm like when auto scaling policy will kick in. So here we are adding alarm like if we are creating alarm like if it goes above 70, then add one machine. If it goes below 40, then remove one machine. So that's what we are doing here. So create alarm, select metrics. So we are going to add average CPU utilization, auto scaling group, CPU utilization, select metrics, period 5 minutes. Let's keep that. So greater than threshold, greater than is equal to, let's keep it 70. Next, auto scaling policy we will add later on. Use existing SNS topic for my demo ASG, that is sending notification to Techinforay. Let's create next alarm name, CPU utilization greater than 70. Next, create alarm. And let's create another alarm for CPU utilization less than 40. Auto scaling group, CPU utilization, select metrics. So lower than equal to 40. Next, create our notification demo ESG. Next, CPU utilization less than 40. Next, create alarm. Okay, so we have our policies in place, alarms in place. So we will create scale in and scale out policies. So in this alarm, you can create alarm based on like network traffic as well. So we can add that all the alarms in this, like we can select metrics. So all these metrics can be selected like based on network ELB traffic. So based on that. So as of now in this demo, I'll show you based on CPU utilization. So we have created the alarm. So let's get back to our auto scaling group. So this one, network auto scaling. So dynamic policies, create dynamic policy. So let's keep simple scaling, policy name, scale in. So, and we are using 40. So scale in means we have desired capacity as 4 number of machines, but in case the average utilization of these 4 machines, let me describe you diagrammatically. So we have 4 machines in place in our desired capacity, right? 1, 2, 3, 4. And there is average utilization for all these machines. So in this policy, dynamic scale-in policy is that in case the average utilization goes less than 40, then one machine can be removed. And again, if after removing this policy, so take action and then wait for another minute, you can mention the number of seconds. In case still the utilization is less than 40, remove another machine. But we have kept our desired capacity 4, minimum 2, maximum 6. So it will come to our minimum capacity, removing 2 machines out of this. And while adding another scale out policy, it will add machines and move it to 6. So in case we have 4 machines, it will add, in case the utilization goes above 70, then it will move to our more than desired capacity. So we will test that as well. So in case the average CPU utilization goes above 70, it will add more machines. So that's automatic scale in and scale out policies. So here, let's add scale in policy. Let me clear drawings. So take action, add, remove machine. 1 capacity units, then wait for 300 seconds. Let's keep it 100. Create. So now the scaling policy is in place. So let's go to our auto scaling group. We can see the activity will start recently because now the average CPU utilization, if we see in our CloudWatch, my demo ASG, so it is less than 40. So this policy will kick in and machines will be removed. So this is the activity history of my auto scaling group. So the scale in policy will kick in over here after a few minutes. So you can here you can see in our activity, so it's in progress. So CPU utilization less than 40, state alarm has been triggered, policy scale in changing desired capacity from 4 to 3. So an instance will be taken out of service and there will be a difference response to in desired capacity and actual capacities, shrinking the capacity from 4 to 3. Automatically, it will ask load balancer to drain the machines. So let's go to our target group. So it will be draining the machines from the target group. Yeah, you can see it has started draining one machine. Target deregistration is in process. So if we go to our instances, so here the machines will be terminated. So these are actual 4 machines. These were terminated for testing purpose. So after a few minutes, you can see one machine will be terminated. So you can see our policy has kicked in and it has removed the machine. So it has been shutting down from 4 to 3 capacity. So let's get back to our auto scaling group. So as per our policy, it will wait for another few minutes, few seconds, and it will kick in another scaling policy because still our utilization is less than 40. So yes, you can see it has directed load balancer to drain out the machine and changing the desired capacity from 3 to 2. So termination of previous machine is in progress. And if we go to our target group in load balancing, it has started draining another machine from the healthy group. Yeah. So first machine, the 4th machine is complete. So it is draining the 3rd machine now. So if we see to our auto scaling group, it is updating the capacity. So desired capacity 2, minimum 2, maximum 6. So if we go to instances, so fourth machine has been terminated, 3 are running. So slowly it, once it is drained, so auto scaling group will terminate the machine, third one also. Activity, so it's, so third machine, fourth machine is completely terminated. So now it's in a process of terminating the third machine and moving the capacity from 3 to 2, because if we go to our dashboard, CPU utilization is still less than 40. Let's add number of utilization. Next, EC2. For more clarity, let's add utilization for number. Create widget. So as of now, we can see as utilization is very less, so it will drain out another machine. So I hope you understand the concept of scale in policy. So let's create scale out policy, and then we will put some stress on the server so that we can increase the state from 2 to 3 and 3 to 4. So let's go to automatic scaling and create another dynamic policy, simple scaling, scale out policy. So here we will select the utilization greater than 70. Add machine, one machine, capacity units, wait for 200 seconds. So great. So our two policies are in place now. So our scale in and scale out policy, these are dynamic policies in place. So let's get back to the activity whether scale in policy is successful. So yes, our two machines are terminated. This is sort of process for scale in policy. If utilization is less than 40, then remove the machines. So it has gone to minimum desired capacity, that is 2. So if we go to instances, so the machines are terminated. So only 2 machines are running. So if we go to load balancing target group, so only 2 machines are healthy now. So that was scale in practical testing. So let's test another scale out policy. Hello everyone, so welcome back to another video for auto scaling group. It was getting lengthy, so I'm just creating the videos in parts. So before in my previous video, we covered as a part of dynamic scaling, we covered scale in policy, and number of instances has been removed. So if we see our auto scaling group, our desired capacity is now 2, minimum 2, and maximum 6. So, and as a part of notifications, we are getting that in the emails. If we check that, so we are getting those notifications. So here it is showing that our auto scaling as a part of EC2 instance has terminate. So it was taken out of service, health checking indicating it has been terminated. So here is the monitor alarm. Alarm CPU 40 is in process. So scale in changing from 4 to 3 and 3 to 2. So you are getting all these notifications in your email. So now let's understand the scale out policy. So we have instances in place too. So let me assign elastic IP to this machine so that we can access this machine. Then what we will do is, let me show you practically. So here we have two machines, right? So for scale out policy, we will, as of now, CPU utilization is very less. As we can see in our CloudWatch, I think it's very less than 1%. So we will put some stress on these servers. There is a stress tool. I'll show you that. So we will put stress on these servers and CPU utilization will go high. Utilization will go high and scale out policy will kick in because we have alarm that in case the utilization, average utilization is greater than 70, then add machines. Okay, so as of now it's 2. So once we put stress on these servers, CPU utilization will go high, scale out alarm will kick in, then scale out policy, dynamic policy will kick in and add one more machine. So this will scale out horizontally like this. So if you understand this concept, let's do this practically. Let me assign elastic IP to this one, 4CA. Elastic IPs, remove it from the previous instance. Disassociate IP, disassociate, associate elastic IP, 4CA, okay, associate. And let's get one more, allocate one more elastic IP to both the machines so that we can put stress on the machines. And demo elastic IP. Stick IP2, save. So allocate this associate IP with second machine that is running associate. Okay, so let's get back to our machines. Instances. So if we open this, refresh. So this has been allocated the elastic IP. So let me connect these machines. Okay, so let's connect these machines. So one is 245 and another is 1.31.245. So I have connected these machines and let's go to this one, 130. So let's sudo su. So let's open that commands. So let's install this tool. This is called stress tool. Run these commands, you can run them. Enter, install. Okay, so it's getting installed. Let's go to another machine, 130, 245. So here also again, let's run those commands. Use this command, okay. Then install the stress tool. So if we see another machine, stress tool is done. So uptime. So it's very less as of now. Let's go to another machine. So it's complete uptime. Okay, so let's use another command to put stress on both the machines. And let's go to another machine. Okay, so now what this command will do, this will put 90% of load on CPU for 5,000 seconds. So let's go to our instances and watch this in the cloud, our CloudWatch. So here you can see the utilization. So slowly this will start increasing and the utilization will go high. So here you can see healthy host as of now 2. So let's wait for a few more minutes. So once this goes above 70, then our policy will kick in, scale out policy will kick in. Let's go to launch auto scaling configuration. So demo ASG activities. So here we will see once this gets kicked in. Let's wait for auto scaling average utilization to go above 70. So let's wait for that. Okay, so now you can see our CPU utilization is more than 70, it's around 84%. So let's get back to our auto scaling group. So let's see if scale out policy gets kicks in. So it will take some time. Let's refresh that target group. So in the target group also, it will register new machines. So as of now, it will show only 2 machines are healthy. So once this policy kicks in auto scaling group, then it will be added into target group of load balancer. So let's see activities. Okay, so we are into our auto scaling group, into activity. So here you can see the pre-in service has been kicked in, and our scale out policy has been kicked in due to the alarm triggered policy scale out changing from desired capacity 2 to 3. So our scale out policy has been kicked in. Average utilization is more than 91, more than 70%. It's around 91. So you will see all those changes. It has been initiated. So let's see our auto scaling group. So desired capacity has been increased. So let's see instances. So it will add one more instance. Yeah, you can see this one is instance. So this is the new instance which gets kicked in due to scale out policy. So it's getting initialized. Before we were having 2 machines only. So now due to CPU utilization more than 70%, it's adding one more machine automatically. So now you can see how automatically due to the load on the servers, the CPU utilization got more than 70%, and automatically one more machine is being added. So once this is done, then we will again review the CPU utilization, average CPU utilization for auto scaling group. Yeah. So it is being initialized. So if we go to our target group in load balancer, so once the machine is ready, here will also start registering. Yeah. So machine is ready, and our load balancer has already added one machine. So auto scaling group, demo ASG activity. Yeah. So capacity has been increased from 2 to 3. And if we see our web page, it's still running. Right. So I hope you understand the concept now. So if we see our average utilization, so that was the main objective. So let's stop stress on the servers. Exit. And another server, this one. Control C. If we see the uptime, so it's around 83. Yeah. So that was a stress tool that was used to put some stress on the server. So if we watch these, so slowly this will come down, and the utilization is it's shown on the dashboard and cloud watch. And healthy host in the load balancer, it has been increased to 3. So you can see all this. So that was the main objective of scale out policy, how we can kick and scale out policy. I hope you understand the concept now. So that's the desired capacity 3. So that was the part of this. So now if we come back to our slide, so we have tested the main part, creation of scale in and scale out policy, then scale in policy testing and scale out policy testing. We have tested all this. Now let's decom this auto scaling process, because what I want to show is this is also again automatic. Automatically all the instances will be terminated. Clear all drawings. So let's get back to our EC2 instance page. Select this, delete. So it is deleting now. If we go to our activities, it will start removing the components from the load balancer. Load balancer will start draining the machines. And once load balancer drains the machine will be terminated from the instances. So that's all automatic. So if we go to our target group in load balancer, demo ASG1. So yeah, you can see draining has been started. So that's you can see this is all automatic. We have just deleted auto scaling group and draining has been started. So once this is done, then we will I'll show you in the instances that they will start getting deleted. So it's load balancer is draining out. Let's go to see the activities and auto scaling group. Activity, yes. So it has asked all the machines to be terminated 320 because we have deleted the auto scaling group, and you will see notification in your email ID also. So if we go refresh it, see the notifications. So this was the alarm triggered for utilization going above 70, increase the capacity 2 to 3. And let me find notification for deletion. So this was again for 70, less than 40. Yeah, this was a triggered desired capacity. Yes. So you will get a notification for this as well. Let's get back to our AWS console. So it has been draining out. Let's see target group. Draining. Okay. So this will start removing the machines as well. So in the meantime, let's remove Elastic IP. That's very important because these machines will be terminated, and if you are not using Elastic IP, then you will be charged for that. Disassociate another Elastic IP and release these IPs. Release them because you don't need them. Okay, let's see instances still running. So as of now, load balancer is draining them. And if we see our CloudWatch, so it's going down and removing the host. So if we see our web page, so this is service is unavailable because we have terminated the load balancer. So still it will take some time for removing the resources. So what I was trying to show is this is all automatic. This has been removed from auto scaling group, all you can see this activity. It has initiated action towards load balancer to drain out the machines. So once this is done, then it will remove the machines as well. So draining is in process. This takes some time. So for all this monitoring, you can go to auto scaling group, and you can see all this activity in ESG activity. So as of now, it's draining. So draining is complete if we see in the target groups of load balancer. If we go to load balancer, yeah, there are no healthy machines. So if we go to auto scaling group, it has started terminating the machines. Go to activity in progress. If we go to instances, yeah, all the machines are terminated. So that was all part of my demonstration for auto scaling group. I hope you have enjoyed it. And these were the steps that we covered in this. And first, we created a web server using Linux machine. Then we created launch configuration. We created auto scaling group. And then we tested the desired capacity that we set during configuration and by terminating the instances. Then also we added load balancer to access the web server over the internet using load balancer DNS. Then we created scale in and scale out policy using CloudWatch alarms. So scale in policy, we tested that, it decreased the capacity. And then we put some stress on the server by using stress tool. So it again increased the capacity from 2 to 3. So in the end, we decommissioned the auto scaling group. Everything was removed automatically. So that was all for this demonstration. I hope you have enjoyed this. So thank you for watching this video, and I hope you have enjoyed it. Let me know in case you have any comments, questions, and doubts. Do not hesitate to contact me or put your questions in the comments. I'll be happy to help you. Thank you. Thank you for watching the video. And I'll keep on posting these exciting videos on my YouTube channel. You can please subscribe to my YouTube channel and get the notifications. Thank you very much. Hello, everyone. I hope you are doing good and safe at your homes. So Techinforay is back with another technical video to share knowledge of AWS cloud concepts. And I have created this YouTube channel to share knowledge with cloud students and aspirants. And I have also created blogs at www.techinforay.com. And you can go through those blogs as well to enhance your technical knowledge related to AWS cloud concepts. And in addition to that, we have also launched AWS Cloud course, and where we are covering the basic general cloud concepts and concepts of underlying technologies like network, server, storage, database, and security, and also covering the challenges in traditional data center, and then slowly moving towards advanced cloud concepts so that concepts can be digested easily. And in case you have a requirement or interested in training, you can contact us and we will help you with that and help you to create complete learning roadmap to achieve industry level cloud knowledge. So this is our YouTube channel called Techinforay, and where we are trying to make learning cloud technology easy, and so that you can grasp the content concepts. So as a part of this uh, practical demonstration videos, I am creating videos for network, compute, storage, and database so that you can get complete knowledge about AWS services that are there in different domains. And you can watch these videos and perform your own practical demonstrations, and you can follow these steps and create your own environment as well. So I hope this helped you to enhance your AWS cloud knowledge, and slowly you can move towards advanced concepts. And I'll keep on adding more videos in this YouTube channel. So you can subscribe to my YouTube channel and keep on getting latest videos for the AWS cloud concepts. So in my previous videos, I have created several videos for different domains. Like in network layer components, I have created how to create virtual data center on AWS cloud or VPC, and creating network components like routing, subnets, internet gateway, elastic IP, NAT gateways, and establishing communication between different VPCs over the cloud, and using VPC peering connection and AWS Transit Gateway. This is a really advanced concepts, and you can try these. Also, I have created videos for establishing IPsec secure VPN connection from AWS cloud to on-premise data center. So I have created videos using VPN gateway and transit gateway. So this is also a really interesting concept, and you can try this, and that'll really help you to enhance your networking knowledge. And as a part of AWS compute layer components, I have created videos for launching Windows and Linux instances, and then adding load balancer in front of the instances, so that to distribute the load. And another beautiful concept of auto scaling group, where you can learn automation in the cloud and automatically scale in and scale out policies. So that will help you to achieve automatic scalability in the instances. So that is also really interesting. You can try that and watch the videos and create your own practical demonstration. So in this video, I'm going to add. We have added network layer, compute layer, and in this I'll add storage layer. So in this first video, I'll create S3 storage. I'll introduce you about the S3 storage, and we will create S3 storage bucket and see different options that are there in the S3 bucket, how different options like tiering options and versioning options. So we'll see that practically. And once the bucket is created, then we will try to access the S3 bucket over the internet using WinSCP, or we can try to access the bucket using AWS Linux instance and using CLI uh, uh, mode, and then we can access through commands the S3 storage. So in this, like in my previous videos, I have created these components of network, like creation of VPC and virtual firewalls, SG security groups. And also I have created videos for launching the instances. So in this video, I have these network components are already in place. So if you want to learn how to create these components, then you can watch my previous videos. So in this video, what I'm going to show is that these components are in place, and we will create AWS S3 storage service, and we will add storage layer in the practical demonstrations. So in this, this is a AWS global service. It's not a regional service. So we will create S3 bucket, and then see the options in the S3 bucket, and then we will log into these machines, Windows machine, and we will try to access this S3 bucket using WinSCP tool. And also we will connect to Linux instance, and we will access the S3 bucket using commands, and also try to create the bucket. So this is the demonstration for this video. So let's move forward and see this practically. So here I'm into my AWS console, and let's create, and this is S3 bucket, AWS Amazon S3 service, and we will create a bucket in this, and this is a global service. That's why you are able to see global over here. So let's create a bucket, click on create bucket, and let's give name Z my demo. So you can add any name, but it should be unique so that you can work on that. So we will create this bucket in Mumbai region. So let's select that AP South 1. And as of now, our public access is blocked, and we will keep these default options: bucket, versioning, and tag. Let's disable this, keep default options for encryption as well. And let's create the bucket. So my bucket is created now. Let's go to the properties of bucket. So from here, we can upload the files into the bucket. So let's upload something. Upload, add files. So here we can go into VPN. This is one of the folders, new folder. So let's select this S3 for test, upload file. Close. So you can see our file has been uploaded. So let's go to the properties. So in properties, you can enable versioning of the file. So you have to enable this while creating the bucket, and enable different multi-factor authentications to avoid delete of the objects in the bucket. And we can add tags also. So let's add tag. So department. So we are creating it for network. So we can add network tag as a department. Save changes. So encryption is by default disabled now. We will add that at the later stage. So this is also quite interesting concept of intelligent tiering archive configuration. So in this let's create configuration. So you can provide configuration name in this. So the main point is that we can archive. These are the archive settings. So in case if we select these options, and if the objects are older than 90 days, and if the objects are minimum 180 days, so it'll automatically go to deep archive access tier. So automatically it'll move to AWS Glacier, and that the objects are not accessed, or here it is mentioned like whole number greater than or equal to 90 or 730 days. So you can mention the number of days if a object is old, not accessed or not used. So it's also mentioned the number of consecutive days without access before tiring down or to the access tier. So any object that's not accessed by these number of days, it will be automatically moved to that deep archive into AWS Glacier storage. And there are some, it's quite cheap, and you will not get more billing for that. So here these are different options in this. So that was about intelligent tiering. So automatically it will keep on checking the objects that are not accessed in the recent time. So it will automatically move to that. So as per your requirements, you can set all these configurations and number of days. And you can create a cloud trail data events to store these in the store the trail in the S3. And also you can create event notification. So in this, like we will cover this in SNS notification, like creation of event name, and what event types you want to get notified. And accordingly you can mention all this, and you can these are the different destinations into Lambda function, SNS topic, SQSQ. So we will create, once we will cover the SNS topic, then we can cover this as well. So what the SNS topic that is created, we need to select that over here and save the changes. So automatically you will get the notifications as well. So that was about event notification, and you can apply object lock policy also. And this is another practical that we will cover called static website hosting. So we will cover this and host a website over the S3 bucket using when we have a requirement of hosting a static website, when we have static content. So these were the various properties of bucket, and you can apply permissions also. So here we are going to access this bucket over the internet. So let's edit this and disable the local access and enable public access. So let's save changes, confirm, and confirm. So now we will be able to access this. So in management, you can apply different policies, lifecycle, replication policies, inventory configuration. So that's about management of the S3 bucket. So let's go to S3 bucket and let's try to access this bucket from over the internet from Windows server. So let's access this. So I have already installed WinSCP, and this is my server over the AWS cloud instance I have shown you in the diagram. So let's select this Amazon S3, so it automatically comes to host name. So let's put the AWS access ID and secret ID. Let me access that. So these are my access IDs, and let me copy this. See, let's go to Windows Server and paste. And AWS secret key. Control C and paste here. Click login. So here you can see this is our bucket that we created over S3. So this is Z my demo bucket, and this is the S3, the demo file we uploaded it. So we can edit it over here also, and then we can add more files also. Let's create one create new file over this server, S3 demo file from Win instance. So we can upload this file. Let's go to desktop and just drag and drop, you will be able to see. So it's automatically uploaded. So that's one way of accessing the S3 bucket over WinSCP over the internet. So if we go to our AWS console, so if we see the bucket, so refresh it, so you can see that we have uploaded this S3 demo file from Windows instance. So you can upload the files in that way from WinSCP also. So let's try to access our from the Linux instance as well. So let's access our Linux instance. I have already created these instances. So let me get the public IP of Linux instance and log in into that. Copy for V. Let's log in into that. Browse Mumbai demo private key. Open. EC2-user sudo su. So here we are into our Linux instance. So here AWS CLI is already installed, AWS version. You can check that. So it's already installed. So to log in into our, let's log in into the CLI AWS configure. So here again, we have to put our the keys that we have generated. So we can use that key. Control C, enter, and again the secret key, enter. Default region name, we have to mention that as well, so it has automatically taken. So in case it's not taken, you have to mention that in which from where you want to access it, and in which region you have created the S3 bucket. So now we can see our AWS S3 LS. So you can see our Z my demo bucket that we created it. So let's see the contents of it. The AWS S3 LS Z my demo. So these are the files that we created on it, like my demo bucket and from Windows instance, and that S3 text file that we created it. So from here also, from like if you want to create any file, like we can create one file using Vim editor, S3 test file, test from Linux. This insert S3 test file created from Linux instance. Escape :wq. So if we see current, it's in pwd. It's in this. So we can copy this file into S3. Copy AWS cp test from Linux to S3 Z my demo. No. cp test Linux, test from Linux. So the command that to copy the file is AWS S3 copy test from Linux to S3 : Z my demo. That's our bucket name. Yes, it's uploaded now. So that's the correct command. We were missing S3 in the previous command. So we can see the message that it has been uploaded from. Also, we can create bucket also, like AWS S3 make bucket and Z my demo 1. AWS S3 S3 : no, still AWS S3. So that was the correct one. So you can create a bucket from also using MV, that is make bucket. So if we go to our AWS S3 console, so this is our console. So here we can see that if we refresh it, so this is the test from Linux that we uploaded it. And if we see our buckets that are created in this, so this is another bucket Z my demo 1 that we created from our CLI Linux instance. So that was it as a part of this demonstration about introduction about S3 bucket and how we can access different ways of accessing the S3 bucket over the internet. So I hope you have learned about S3, about introduction, about different options that are there in the S3 bucket. And in the more videos, I'll also enable how we can access S3 bucket using endpoints and accessing the bucket locally. I'll create another video for that, and also I'll create one video for enabling S3 static website over the S3 bucket. So that was it for this video. Please like and subscribe to my YouTube channel so that I can reach more and more people to share my knowledge. Thank you. Hello, everyone. I hope you are doing good and safe at your homes. So Techinforay is back with another technical video to share knowledge of AWS Cloud concepts. And I have created this YouTube channel to share knowledge with cloud students and aspirants. And I have also created blogs at www.techinforay.com. And you can go through those blogs as well to enhance your technical knowledge related to AWS Cloud concepts. And in addition to that, we have also launched AWS Cloud course, and where we are covering the basic general cloud concepts and concepts of underlying technologies like network, server, storage, database, and security, and also covering the challenges in traditional data center, and then slowly moving towards advanced cloud concepts so that concepts can be digested easily. And in case you have a requirement or interested in training, you can contact us and we will help you with that and help you to create complete learning roadmap to achieve industry level cloud knowledge. So this is our YouTube channel called Techinforay, and where we are trying to make learning cloud technology easy, and so that you can grasp the content concepts. So as a part of this practical demonstration videos, I am creating videos for network, compute, storage, and database so that you can get complete knowledge about AWS services that are there in different domains. And you can watch these videos and perform your own practical demonstrations, and you can follow these steps and create your own environment as well. So I hope this helps you to enhance your AWS cloud knowledge, and slowly you can move towards advanced concepts. And I'll keep on adding more videos in this YouTube channel. So you can subscribe to my YouTube channel and keep on getting latest videos for the AWS cloud concepts. So in my previous videos, I have created several videos for different domains. Like in network layer components, I have created how to create virtual data center on AWS Cloud or VPC, and creating network components like routing, subnets, internet gateway, elastic IP, NAT gateways, and establishing communication between different VPCs over the cloud, and using VPC peering connection and AWS Transit Gateway. These are really advanced concepts, and you can try these. Also, I have created videos for establishing IPsec secure VPN connection from AWS Cloud to on-premise data center. So I have created videos using VPN gateway and transit gateway. So this is also really interesting concept, and you can try this, and that'll really help you to enhance your networking knowledge. And as a part of AWS compute layer components, I have created videos for launching Windows and Linux instances, and then adding load balancer in front of the instances so that to distribute the load. And another beautiful concept of auto scaling group, where you can learn automation in the cloud and automatically scale in and scale out policies. So that will help you to achieve automatic scalability in the instances. So that is also really interesting. You can try that and watch the videos and create your own practical. So in my previous videos, as a part of storage layer components, I have created video for introduction to S3 bucket and its features, that the different options that are there in the S3 bucket, and its properties. And we also created S3 bucket, and then we access that S3 bucket over the internet from Windows instance using WinSCP, And also we access the S3 bucket from Linux instance using AWS CLI commands. And also there was another video for storage layer components, and we hosted a static website over S3 bucket. And that was quite interesting video. I hope you have seen that. If you haven't seen that, go back to the another video, and you can, as a part of storage layer, you can watch these videos, and these are quite interesting concepts for accessing S3 bucket and hosting a website. So in this video, we will cover another use case as a part of storage services. So in this, what we are going to do is that we are going to create S3 endpoint, because in my previous demonstration, we have accessed our S3 storage bucket over the internet, but there are certain charges for flow of traffic and accessing the S3 bucket. But to avoid those charges, we have an alternative to create S3 endpoint. So in this video, what we are going to do is that we have already created the instance and the some of the steps that you can follow, that creation of instances in public and private subnets. And what we are going to do is we are going to access this S3 bucket from our private subnet, the instance that is not having internet access, so that the traffic should not flow towards internet. So we will enable S3 endpoint, and then we will automatically this S3 endpoint will be attached to the subnet, to private subnet, and then also we have to create an IAM role and attach that to that private subnet instance, so that it can access to this S3 bucket privately over the local network in AWS. So in this case, the network will not move towards internet. It will be locally, and you will not be charged for that. So in this case, also a use case can be that the customer wants to access AWS Global S3 service over local network, and because we do not want to charge extra creation of billing for transfer of data. And this is another way of optimizing the cost in AWS infrastructure. So by the end of this lab, you will be able to access S3 bucket over local AWS network without going over the internet, and we are achieving cost optimization. And also we can see create bucket from AWS CLI. So let's move forward to our AWS console, and let's see the S3 storage bucket and creation of endpoint. So here we are into our S3 storage, and S3 bucket is already created. The main objective of this lab is that to access this bucket, how we are accessing this bucket locally over the local network in AWS. In case you want to learn how to create this bucket, you can watch my previous video. So this my demo bucket is already created. So let's stop public access for this bucket, and then we can move forward. Properties, permissions. So we are editing the public access, block all public access, because we are going to access locally. Confirm. Okay, from access permissions perspective, buckets and objects are not public. So let's go to our EC2, VPC, and create endpoint for it. Let's go to Mumbai region. So here into VPC, we are going to go over endpoints, and it's already, this is previously created. Let's delete this, delete endpoint, yes, and create a new endpoint. So in this, you can see there are different AWS services and there are certain endpoints available for them. So let's create for S3. So we have gateway, endpoint gateway for S3 bucket. And let's select the VPC in VPC1, and we are going to attach it with the private subnet. So full access to S3, that is the policy that is attached to this endpoint. And let's add the tag department network create endpoint. So our endpoint is created. Let's close, and it is available now. So let's assign the role, IAM role, to the instance that we are going to access it. So if we go to EC2 instances, running, and this is the private instance from which we are going to access this S3 bucket over the endpoint. So this is not having any public IP address, and this is in the private subnet. So let's go to this instance and assign a role. Instance actions. Let's select this instance actions, security, modify IAM role, choose role, EC2 S3 role, save. So we have applied a role to the machine. So what I'm going to do is I'm going to access the uh, Windows instance that is there in the public subnet, and then from there I'll access this private subnet instance because it's not having internet access. So here I am into my public Windows instance, and from there I'm accessing my private instance. So let's try to access the S3 bucket. So here I'm into my private instance. So let's first log in into AWS configure, and let's put our ID that we used before. So here we are using AWS CLI to access the bucket. So let's use this. Enter. Do not forget to mention the region name. So here we are using AP South 1 Mumbai. So let's see if we can access our bucket AWS S3LS. Yeah. So this is the bucket that we have created in AWS S3 service, that is ZMyDemo. So let's see the contents of this bucket. AWS S3 S ZMyDemo LS. Oops. AWS S3 ZMyDemo LS. I think there is some wrong use of command. Let me try again. AWS S3 LS, we can see the bucket. AWS S3 LS ZMyDemo. Yes, now it's okay. So these are the files that if you remember that we created while accessing it over the internet. So these are the same files, and we are accessing the same bucket from local network. So here we can create a bucket also. So AWS make bucket, AWS S3 make bucket ZMyDemo 2. Okay, we have to give complete URL S3 : S3. Please avoid these small mistakes, else you will not be able to achieve the results. Okay, so our bucket is created. So let's list the buckets AWS S3 LS. Yes, so all these buckets are created now. So let's move forward. Let's go to our console. So this is AWS console, and let's refresh it. Yeah, you can see this bucket that we created from AWS CLI. So also, if you want to see that how we are creating a role that we attached it, let's go to IAM. So roles, go to roles. Although this is a part of management services, but let me show you how you can create a role in this. Create a role. And let's create it for EC2. Next, we are going to give complete access for S3. And let's access S3 full access. Next, tags, department, network, review. Okay. AWS demo EC2 endpoint role. So this is a role that we created it. Create a role. Yeah. So our role is created. So let's. So this is how you can create a role also for EC2 instance for resources, for any resources that is there in the AWS, and allocate access and control the access to different resources. So if we go to EC2 instances, so you can modify any role or apply role to that instance. So if we go to instances, so this is our private instance 10.1.2.179. So if we go to the instance actions, security, modify IAM role. So we have previously selected this EC2 S3 role that was already created. So we can change that role also that we created now. So this is how you can apply a role to a instance. So that was it for the part of this demo, that accessing the S3 bucket over the local network and applying the role to the instance and accessing through AWS CLI. So I hope you have enjoyed this, and please like this video and subscribe to my YouTube channel and for more exciting videos. Thank you. See you in another video. Hello, everyone. I hope you are doing good and safe at your homes. So Techinforay is back with another technical video to share knowledge of AWS cloud concepts. And I have created this YouTube channel to share knowledge with cloud students and aspirants. And I have also created blogs at www.techinforay.com. And you can go through those blogs as well to enhance your technical knowledge related to AWS cloud concepts. And in addition to that, we have also launched AWS Cloud course, and where we are covering the basic general cloud concepts and concepts of underlying technologies like network, server, storage, database, and security, and also covering the challenges in traditional data center, and then slowly moving towards advanced cloud concepts so that concepts can be digested easily. And in case you have a requirement or interested in training, you can contact us and we will help you with that and help you to create complete learning roadmap to achieve industry level cloud knowledge. So this is our YouTube channel called Techinforay, and where we are trying to make learning cloud technology easy, and so that you can grasp the content concepts. So as a part of this uh, practical demonstration videos, I am creating videos for network, compute, storage, and database, so that you can get complete knowledge about AWS services that are there in different domains, and you can watch these videos and perform your own practical demonstrations, and you can follow these steps and create your own environment as well. So I hope this helped you to enhance your AWS cloud knowledge, and slowly you can move towards advanced concepts. And I'll keep on adding more videos in this YouTube channel. So you can subscribe to my YouTube channel and keep on getting latest videos for the AWS cloud concepts. So in my previous videos, I have created several videos for different domains. Like in network layer components, I have created how to create virtual data center on AWS cloud or VPC, and creating network components like routing, subnets, internet gateway, elastic IP, NAT gateways, and establishing communication between different VPCs over the cloud, and using VPC peering connection and AWS Transit Gateway. These are really advanced concepts, and you can try these. Also, I have created videos for establishing IPsec secure VPN connection from AWS cloud to on-premise data center. So I have created videos using VPN gateway and transit gateway. So this is also a really interesting concept, and you can try this, and that'll really help you to enhance your networking knowledge. And as a part of AWS compute layer components, I have created videos for launching Windows and Linux instances, and then adding load balancer in front of the instances, so that to distribute the load. And another beautiful concept of auto scaling group, where you can learn automation in the cloud and automatically scale in and scale out policies. So that will help you to achieve automatic scalability in the instances. So that is also really interesting. You can try that and watch the videos and create your own practical. So in my previous videos, as a part of AWS storage layer components, I have covered S3 storage bucket, and in my previous video, I introduced you to S3 bucket and its features and different options that are there in the S3 bucket, and creation of S3 bucket, and then accessing it over the internet from Windows instance using WinSCP, and then accessing the S3 bucket from Linux instance as well using AWS CLI. So these were different ways of accessing S3 bucket over the internet from Windows and Linux instance. And in the next video, I created S3 bucket and hosted a static website over the S3 bucket, and that was quite interesting video. And then in the later part of video, I created S3 endpoint, because if we access S3 bucket over the internet, then there are charges of traffic flow. So there is another way of accessing S3 bucket over the local AWS network, and that is by creating S3 endpoint. So these were the few concepts that I have covered in my previous videos as a part of storage layer components. So in this video, let's move forward and cover another service of storage services in AWS. So in this, I'll cover EFS storage system, creating a file system in AWS and then accessing it over the two systems, and then we can see the files. So these are a few steps in this that I have already created instances in this. So if you want to create this demonstration from scratch, so you can log in into AWS console and create instances, and then attach elastic IP to access the instances, add root so that they can have internet access, then go to EFS service, and then we will create file system and customize it, create a customized file system as per our requirements. And then we will create a mount point on both the Linux machines, and then we will create some files in the mount point. And then you can see both the machines are having same files in the the mount point that we are going to create. So by the end of this demo, you will be able to see understand the concept of EFS storage system, that is elastic file system, and creation of mount points on the Linux instances. And then you can see file system on both the instances on Linux instances. So let's move forward and on the AWS console and create this EFS, Elastic File Storage System. So I am here into my AWS console. Let me clear the drawings. So here I have created these instances, that is Linux instance and Linux 2 instance in my VPC1. And so we will access these instances. Then on these instances, we will mount the EFS storage system. So let's go to storage and EFS and create our file system. So here in EFS, let's create file system. So let's demo EFS. We will select our VPC1 one zone, then AP South 1. Let's click on customize it, and then we will select our settings. So let's keep default everything, disable backups, general purpose, and no need of encryption as of now. So these are the settings that we can mostly, let's keep it for default for demo purpose. So let's department we are creating for network. Next, and availability zone 1 subnet, we are going to use private 1, private VPC 1, sorry, public automatic SG. Let's select our public VPC1. Next. So guys, keep this in mind while configuring network access. Please select security group, as else you will not be able to access the file share system. Select the while working on network access, select availability zone, subnet ID with a bit care, so that correct access is enabled on the file share system. So let's move next. These are the file system policies that we can apply. Let's keep default. So let's create our file system. So this is creating, still the status is creating. So it's available now. Let's create our network point. Network. So it's getting created so that we can use this one, this IP for enabling the mount point. So it's getting created. Okay, so our mount point is ready now. So we will use this IP address while mounting the file system. So I have copied some commands. So let me update those commands. So we will use these commands. I'll copy these commands in the comments, and you can use these commands for your reference. So let me update the commands with the IP address, and then we can run these commands on the Linux instances that we created. So just for reference, let's go back to the diagram just for explanation. So this is our diagram, and as a part of storage layer, we are creating this EFS file system, and we have created this elastic file service in AWS, and we will create a mount point, and then we will access this mount point from our Linux machines that I have created it on the public subnet. So let's, I hope you understand the diagrammatically, and the picture is clear. And as a part of storage services, we are creating this video, and let's move forward and implement this. We have already created this. Let's configure some commands on the Linux instances and see how we can access the file system. So let's move forward to the instances. So this is our public instances. Let me initiate new session. ec2-user sudo su, get into super user. Let's close this. Okay, another Linux machine. Duplicate session. ec2-user. Let's get into super user. That's it. Okay. So here are two machines that I've shown you on the diagrammatically. So we will access this file storage system from these machines. So let's first create a mount point on Linux machine 1. So let's access this. So let's install these utilities for EFS. Okay, let's create a directory for mount point. Okay, that's done. Let's create a mount point now. I think there is some access problem. Let me check 1 second. So just ensure that you have all the access on the mount point. So let's try to create it. Okay, our mount point is created, and let's run other commands. ls al. So these are the currently files in the current mount point. Let's change some permissions. Okay, done. So let's create some instances, files in the mount point. Okay, that's done. ls -n. Okay, so these are the instances that we have created on the mount point. Let's go to other instance and run these commands on another one. Download the utilities. I think I have to again create a duplicate session. ec2-user sudo su. Okay. So let me run this command to install the EFS utilities. Create mount point. Sorry, mount directory. So let's create a mount point now. That's done. So let's get back to mount point now. ls. Change the permissions. Okay, and create some files on the second machine also. So if we see files, we should be able to see all the files. So this is files created. ls -l. Just a second. Mount point already mounted. Okay. ls -l. So I was creating in wrong directory. So I'm into now correct the directory now. So we are into cdefs and created files on this using touch command. So now we can see all the files that are created in both the mount points and on this second machine as well. Also, let's try to create a file using Vim editor and edit the files as well. So let's create a Vim test file and update this file. I for insert test file from instance file created from instance 1 escape colon WQ. So if we see ls minus al, so our test file is created now. So if we see on another, let's go to another machine now, ls minus al. So we can see same file is here also. So let's try to update this vim test file. So we can see the same contents on machine 2 also. So if we insert and update this and updated from instance to escape colon WQ. So if we go to first instance and ls minus al, ls space minus al and vim test 5. Yeah. So you can see that this has been created from instance 1, then we move to instance 2 and updated the file, and then we are back to instance 1, and then we can see that same file has been updated and we can see the same file on both the instances. So that was it for this part of video. I hope this creation of EFS file system and creation of elastic file system AWS, creating the mount target and then accessing it from these Linux instances, Linux instance 1, Linux instance 2. So on both of these, we have configured the file service mount point and accessing it. Then from both the files, we created some files and we are able to see all those files both on the same system. So I hope as a part of EFS, I hope you have enjoyed the concept and uh, do like the video and subscribe to the YouTube channel. And for more exciting videos, you will keep on getting the notifications. So thank you for watching the video. See you in another video. Thank you. Hello, everyone. I hope you are doing good and safe at your homes. So Techinforay is back with another technical video to share knowledge of AWS cloud concepts. And I have created this YouTube channel to share knowledge with cloud students and aspirants. And I have also created blogs at www.techinforay.com. And you can go through those blogs as well to enhance your technical knowledge related to AWS cloud concepts. And in addition to that, we have also launched AWS Cloud course, and where we are covering the basic general cloud concepts and concepts of underlying technologies like network, server, storage, database, and security, and also covering the challenges in traditional data center, and then slowly moving towards advanced cloud concepts so that concepts can be digested easily. And in case you have a requirement or interested in training, you can contact us and we will help you with that and help you to create complete learning roadmap to achieve industry level cloud knowledge. So this is our YouTube channel called Techinforay, and where we are trying to make learning cloud technology easy, and so that you can grasp the content concepts. So as a part of this practical demonstration videos, I am creating videos for network, compute, storage, and database so that you can get complete knowledge about AWS services that are there in different domains. And you can watch these videos and perform your own practical demonstrations, and you can follow these steps and create your own environment as well. So I hope this helped you to enhance your AWS cloud knowledge, and slowly you can move towards advanced concepts. And I'll keep on adding more videos in this YouTube channel. So you can subscribe to my YouTube channel and keep on getting latest videos for the AWS cloud concepts. So in my previous videos, I have created several videos for different domains. Like in network layer components, I have created how to create virtual data center on AWS cloud or VPC, and creating network components like routing, subnets, internet gateway, elastic IP, NAT gateways, and establishing communication between different VPCs over the cloud, and using VPC peering connection and AWS Transit Gateway. These are really advanced concepts, and you can try these. Also, I have created videos for establishing IPsec secure VPN connection from AWS cloud to on-premise data center. So I have created videos using VPN gateway and transit gateway. So this is also really interesting concept, and you can try this, and that'll really help you to enhance your networking knowledge. And as a part of AWS compute layer components, I have created videos for launching Windows and Linux instances, and then adding load balancer in front of the instances, so that to distribute the load. And another beautiful concept of auto scaling group, where you can learn automation in the cloud and automatically scale in and scale out policies. So that will help you to achieve automatic scalability in the instances. So that is also really interesting. You can try that and watch the videos and create your own practical. Okay, and as a part of storage layer components, in my previous video, I have provided introduction to S3 bucket and its features. And also we see how we can create S3 bucket, and then uploading some objects to it from AWS console, and then accessing it over the internet using internet from Windows instance using WinSCP, and also we tried to access the S3 bucket from Linux instance using AWS CLI mode. So that was part of my previous video. So in this video, as a part of this practical video, we will cover storage services, but in this we will create a static website that we are going to host it over Amazon S3 service. So we will log into AWS console, and then go to storage services, and we will create one S3 bucket, and then we will upload our content that is for the static website, and enable public access to those objects in the bucket, and we will update the content for S3 static website, and then we will access that website over the internet. So it's a sort of like publishing a website over S3 bucket, and another way of publishing website. And also you might have seen that in my previous videos, we have created web server over Linux instance and Windows instance, and then published our web page over the instances. So this is another way of publishing your website over S3 bucket. So as per the if we talk about solution designing perspective, as per the customer requirements, so this can be also a use case where you can suggest customer to host website over S3 bucket. So let's go to AWS console and see how we can publish a website over S3 bucket. So this is our web S3 console for AWS, and this is a global service. So let's create a new bucket for S3. Z my demo static website bucket. So we are going to create it again in Mumbai, and we will allow public access over it because we are going to publish the objects over the internet. And I acknowledge that current settings might result in this bucket and objects becoming public, and we are aware about this. That's okay. So let's add tag. So this site is for network. So let's create that tagging, create a bucket. So our S3 bucket for static website has been created. So let's move to it and upload the objects for this. So let's upload the objects. Click on upload, then add files. So here we will add files. Cancel. No, we are not uploading. Go to S3 demo website and we have to go to properties. First, let's enable S3 static website hosting. So here, if we go into our properties of our website, sorry, S3 bucket that is created for a website, let's go to static website hosting and click on edit. And we are going to enable static website hosting. So we are going to host a static website and index document, index.html, error document.html, the files that we are going to upload and save changes. So this has been enabled and a DNS name has been created for it. So if we try to access this one, so let's try that. Control P, enter. So as of now, we haven't uploaded anything. So let's upload some. So we are getting forbidden error, so access denied. So let's upload some our documents to this bucket, and then we will see our website. So let's upload our files, add files, and let's web page. Let's rename this index.html, index.html, and this is our error HTML. Save, upload index, open, then add error file, open, and upload. So this is uploading the files to our static S3 bucket for which we are doing it. So let's also, we need to publish these objects, close, and select these objects, go to actions and make them public. Make public, close. So our content is ready. So mostly what we do is we have created this file for demonstration only. So mostly we ask our application guys to provide the code for website, and then you can upload it on the S3 bucket as well. So that's another way. And if we go to our site, so let's refresh it. Yeah. So that was the demo page that we uploaded it. And if we, so our website is up and running from our S3 bucket. So static website served from Amazon S3 as a part of static website demo. So if we want to edit the contents, so let's go to the folder and edit our index file, open it with Notepad, and we can edit it. Served from S3 static website demo, the updated content. So let's save this, Control S, save, go back to our site, and we can remove this, delete, permanently delete, permanently delete, delete the object, close, and let's upload our updated file, add file, index, open, upload file, close. Let's make this index file that we uploaded just now, and let's make it public. Make public. Okay, close. Okay, so let's see. Let's go back to our website and see whether it is updated. Yes. So the content is updated now over the internet. We are accessing this over the internet. So the website is updated as per our updated content. So how easily you can see that we have updated our files into our Amazon S3 bucket and created a website hosting for static content. So you can see how easily there is another way of hosting a website over S3 bucket. So I hope this concept of publishing a website over S3 bucket is clear to you, and I hope you have enjoyed the video, and you can create your own S3 bucket and publish these websites, and you can create your own index.html file and error.html file for your also, and upload those files in the S3 bucket, and use that if you go to properties, and in the end you can see the DNS name that has been allocated to this static website hosting. So that was all for this part of video, and I hope it's clarified this concept of hosting a static website over S3 bucket. So in case you like these videos, please like them and subscribe to my YouTube channel so that you can keep on getting updates about amazing AWS cloud concepts. Thank you for watching. See you in another video. Thank you. Hello, everyone. I hope you are doing good and safe at your homes. So Techinforay is back with another technical video to share knowledge of AWS cloud concepts. And I have created this YouTube channel to share knowledge with cloud students and aspirants. And I have also created blogs at www.techinforay.com. And you can go through those blogs as well to enhance your technical knowledge related to AWS cloud concepts. And in addition to that, we have also launched AWS Cloud course, and where we are covering the basic general cloud concepts and concepts of underlying technologies like network, server, storage, database, and security, and also covering the challenges in traditional data center, and then slowly moving towards advanced cloud concepts so that concepts can be digested easily. And in case you have a requirement or interested in training, you can contact us and we will help you with that, and help you to create complete learning roadmap to achieve industry level cloud knowledge. So this is our YouTube channel called Techinforay, and where we are trying to make learning cloud technology easy, and so that you can grasp the content concepts. So as a part of this practical demonstration videos, I am creating videos for network, compute, storage, and database so that you can get complete knowledge about AWS services that are there in different domains. And you can watch these videos and perform your own practical demonstrations, and you can follow these steps and create your own environment as well. So I hope this helps you to enhance your AWS cloud knowledge, and slowly you can move towards advanced concepts. And I'll keep on adding more videos in this YouTube channel. So you can subscribe to my YouTube channel and keep on getting latest videos for the AWS cloud concepts. So in my previous videos, I have created several videos for different domains. Like in network layer components, I have created how to create virtual data center on AWS Cloud or VPC, and creating network components like routing, subnets, internet gateway, elastic IP, NAT gateways, and establishing communication between different VPCs over the cloud, and using VPC peering connection and AWS Transit Gateway. This is a really advanced concepts, and you can try these. Also, I have created videos for establishing IPsec secure VPN connection from AWS Cloud to on-premise data center. So I have created videos using VPN gateway and transit gateway. So this is also a really interesting concept, and you can try this, and that'll really help you to enhance your networking knowledge. And as a part of AWS compute layer components, I have created videos for launching Windows and Linux instances, and then adding load balancer in front of the instances, so that to distribute the load. And another beautiful concept of auto scaling group, where you can learn automation in the cloud and automatically scale in and scale out policies. So that will help you to achieve automatic scalability in the instances. So that is also really interesting. You can try that and watch the videos and create your own practical. So in my previous videos, as a part of storage layer components in AWS, I have created various videos to introduce you about the storage layer components in AWS, like S3 and EFS. In S3, I have created videos for creation of S3 bucket and its features. And then we have created S3 bucket and accessing it over the internet from Windows instance, and using WinSCP and Linux instance using AWS CLI. And then I also created another demonstration for hosting a static website over S3 bucket. And then we also seen that how we can access S3 bucket over local AWS network using S3 endpoint, because if we are accessing S3 bucket over internet, then that is chargeable. But from cost optimization standpoint of view, then we can use S3 endpoint to access the S3 bucket over local AWS network. Then I have created EFS storage service, and in that we created the EFS file system, and then mounting that EFS file system on different Linux machines, and the creation of different files, and checking whether we can see the same files. And also we created updated one file from one Linux machine, and then again updated from another Linux machine, so we can update the same contents of the file from different systems, and we can see the same contents on different systems. So that was part of storage layer components. Let's move forward and move towards database concepts. So in AWS database service, I'm going to create another practical demonstration, and I'll create this video for AWS database services. So in this, what we are going to do is that we are going to cover 3-tier architecture and 2-tier architecture and database for more clarity of concepts. So in this, we will log into AWS console and create instance in public and private subnet. And then we will attach IP addresses to a public subnet instance and access the public instance, and then addition of routes so that we can access that instance over the internet. So if you want to perform these steps, you can watch my previous videos, and then you can see how we can create different network components and addition of different instances. So once this instance is ready, then we will install application one application which is called inventory application from AWS, and we will create this as a web server on the public instance. So we will install it will act as an application server as well as web server on the same instance. Then we will go to RDS service and create our RDS database, that is SQL based database. And then after that, once database is created, then we will access application over internet and create a connection to the database and perform operation on the database from web application, which will be a sort of 3-tier architecture. Then after that, what we will do that we will install MySQL client on the same instance, and we will perform database operations from command line. That will be a sort of two-tier architecture. So that was a little bit introduction about this practical. Let's move forward. So this is the diagram in this, that this is two-tier architecture and three-tier architecture. This is two-tier architecture. We will install MySQL client on this and access and update the database. And then another is that we are going to install application and access application over the internet and update the database. So in this, what you will gain in this, that launch of database using RDS service, launch of application servers, automatically install an application on EC2 instance that can also be achieved, accessing the application over browser, updating database from the browser, and then we will access database from the instance and updating the database from the same instance using MySQL client. So in this, from database perspective, you will understand about the two-tier architecture, and then demonstration about three-tier architecture. So let's move forward and bit more drawings about the database service. So in this, we will install database in private SG, because we are not going to publish this database over the internet, but we will install application and web layer on public security group and public subnet, and we will expose this network towards the internet, and this will be a secure, and this will not be exposed to internet. And accordingly, we will update the private and public virtual firewalls, which is called security group. So, and this we can demonstrate like two-tier architecture and three-tier architecture. Three-tier architecture means we are going to access this web server and application server over the internet and perform operations on the database. Later, we will install MySQL client on this instance and update the operations on the database. So that will be a sort of two-tier architecture, and this will be a sort of three-tier architecture. So in my previous videos also, as a part of different layers, I have added components and network layer, compute layer, storage layer, database layer. So it's a sort of like we are creating a complete solution design and completing all the different layers and creating a complete solution for customer, and that will be a sort of using different AWS services at different layers. So that will help you to clarify how we can use different AWS services at different layers and how we can create a complete solution for customer. So let's move forward and create these different layers and create this architecture in database. So let's go to our AWS console and first install application on this instances. Okay, guys, I'm into my AWS console, and here this is my VPC in which I'll install the database and my instances. So this is my VPC, and if I go to subnets, I have created different subnet for public and DB subnet for secure purpose, for they are not having access to internet. So they will have access from public subnet only, not from internet. So these are different subnets. So just to go to instances, I have created this one instance, and I'll just make it this instance as a web server and application server. So let's log into the instance and create this as a web server. So let's get into super user, and I have written some commands. Let's run these commands. Let's install the MySQL client on this. And then let's install PHP. And then let's install this application from AWS just for demonstration purpose. and then we can use to access this application over the internet. Let's unzip it into HTML directory. Done. Let's download another application, and I'll copy paste all these commands and you can use them. Okay, so our application and web server are ready. Let's start the service. Okay, and let's start the service. Okay, our server is ready now, and let's try to access this public IP over the internet. Copy this and HTTP. Yes, our inventory system application is ready and we are able to access it over the internet. Let's assign this one role that is required on this instance. Let's go to IAM and look into this role, IAM, so that it can access this application. Roles. So here inventory role, I have created one. Inventory app role. So this is a role that we have to apply on the EC2 instance, and this what we have is we have we have attached this policy for access on the application. So you can create a similar role on your demonstration. That is, this is system manager. So you can add the same policy and then attach to the role. So you can create this inventory app role on the identity and access management, and this role will be ready, and then we will apply this role to the instance. So let's go to EC2 instance. So these are our instances that are running. So we are accessing this instance, and let's apply this role to the instance. Security, modify IAM role, inventory app role. Save. Now if we refresh this, then it will be able to retrieve the role. So it has access to application. Now we are not getting that error. So let's create our RDS database. Then we will edit these settings for this application and access the database. So let's move forward to RDS databases, RDS database. So if we go to the diagram, so we have created this server and installed web application, web server and application. So let's move to the SQL database and create the database for it. So here we are into our RDS, and let's go and create our database. Before that, we have to create one subnet group so that same can be used in the while creating a database. So let's create our subnet demo subnet group for RDS. So let's select our VPC 1 and availability zone. We are going to use 2 zones, and our subnet, that is one subnet that we created for database 4 and 5. So these are our database subnets. If we see our in VPC, so we will place our database in this 1040, and for high availability, we are creating this database subnet group. So let's create it. So our subnet group is ready. So let's get back to dashboard and create a database. So let's click on create database. So in this, we will select standard one, and let's select MySQL database. Let's keep this everything default and select free tier because we are going to use this for demo purpose. Name of the database, inventory -db. So here we are going to use db admin. Master password you can give as per your choice. Lab password. Lab password. So here we are going to use free tier. So T2 micro is our free tier, and storage we are not going to auto scaling. We are going to use basic one. Let's keep everything default in this, and these are all default. Please ensure that you are using correct one and use the same. Remember the password and usernames so that you can use it while configuring the application. So connectivity, we are going to place it in VPC 1. Okay, and subnet group, our demo subnet group, public access, no. So existing VPC, security group, DB, default, let's remove that. Security group, we are applying virtual firewall, which is called security group DB. So for additional settings, we are going to access on 3306 port, additional configuration, database name, inventory. Okay, let's keep everything default. Enable automatic, let's disable it. No monitoring required, no maintenance. Okay, okay. So yeah, that's all. Let's click on create database. So this will take some time, and in the meantime, I'm pausing this video. So once this is created, then I'll resume the video. Okay, our database is ready now. Let's connect this database over the inventory application. Let's copy this endpoint details and paste it on in our application. So let's go to settings. So this is our inventory system that we have installed on the web server and application server. So endpoint is our database inventory -db admin lab password, that is the password. Database is inventory. Save. Yeah, so now we are able to access our database over the application. So if we go to our three-tier architecture, so we have achieved it. So this is like this. We have installed application layer and web layer and accessing it over the internet. And we have installed SQL database layer, and we have accessing this database from application, and application is being accessed over the internet. And we have applied different security groups, firewalls on the database. So let's move forward and perform some operations. Let's go back to the application. So if we add inventory, so store, if we say Delhi item pen quantity 7, submit. So let's add two, 3 more. US item pencil quantity 10, submit. So see, you can update the database also. Let's add 2, 3 more lines. France shoes 10. So we are just updating the inventory. Also, you can delete this one. So delete it. You can perform these options that has been done. We can edit this also. So if we change it to 11, submit. So that was, I think that's clarified that we are accessing the database using the application. So let's go to the instance, and from there, let's perform the operations from the MySQL client. Let me create a duplicate session for this. EC2-user. So we have already installed MySQL client on this, and let's connect to the database. So I have copied some of the commands, and I'll copy these commands in the comments. You can use those same commands. So MySQL is already installed, and let's connect to our database. So let me copy our handler from the database. Let's go to AWS console. Inventory system, AWS console. Inventory DB. Paste. Let's use this command to connect our database. Lab-password. Okay, so we are into our MySQL database. We have connected it using our. So previously I have explained you 3-tier architecture. Now I am accessing the database from the instance. So it is a sort of 2-tier architecture. So let me run some more commands. So if we show databases, so we can see our database, that is inventory database is in place. So let's get into the our database. Okay, we are into our database. Let's show tables. So our table inventory is in place. So let's try to update the query. So let's insert this item into our database. So if we go to our application, so refresh it, we can see that entry into this. We have entered entry for Hyderabad. Yeah, so you can see this one. So that was another way of accessing the database from the MySQL client on the instance. So that was it for this part of database practical demonstration. I hope different concepts are clear, like creation of database, creation of web layer and application layer, and accessing that application over the internet, then creation of RDS database, and connecting the database from the application, and then accessing that application over the internet and updating the database. Later, and this we demonstrated our 3-tier architecture. Later, we logged into this instance, and using MySQL client, we are connecting the database directly and achieving 2-tier architecture. So I hope you have enjoyed the video, and please like the video and subscribe to my YouTube channel, and I'll keep on updating the YouTube channel with exciting videos, and that will help you to enrich your AWS cloud knowledge. And keep watching these videos. Thank you.